Hello, welcome back to the Biki Consult. And today on our channel, we'll be having another series of marathon. We shall be looking at the complete design of a ground plus two suspended floor that will be sitting comfortably on a raft foundation. The good or the most interesting thing about this series is it gives you a full overview of what you are expected to do the moment you receive an architectural file. It could be from the client, it could also be from the architect. So it gives you a full overview of the processes you are supposed to follow until you come out with a detailed design. Due to the uniqueness of every architectural file, in the process of your design, you are expected to encounter some issues, which we also get to encounter in the course of this series. But despite these issues, your role as a structural engineer in the project, you are expected to still provide a safe, durable, and economical design that at the same time meets the functionality of the structure and can still maintain the aesthetics that was proposed to the client or was designed by the architect. And to achieve this aim, we shall be using the architectural floor plans, the elevations, the 3D Revit model, and also the 3D rendered view in order to move this structure from the general arrangement phase onto your final design phase, both for the superstructure and for the substructure. So to practice with us, you can follow the link in the description to get the architectural AutoCAD file, and you can also get that combined with the architectural Revit file. So the advantage that comes with the architectural Revit file is we'll be able to provide an additional floor plan that you can practice at your own free time. So as earlier said, we'll be kickstarting this design course with our general arrangement phase or our GA, right? Because this is more like the most important phase for you as a structural engineer when you are about to perform any design. And why this phase is important is this is where you get to pick the positions of your proposed structural members, which could be your columns, could be your beams, it could be your slabs, or any other structural members you intend to use to achieve your safe and stable design. So this is the phase where you choose the appropriate positions of this member and decide how you intend to connect them together to give you that rigid or to give you that flexible frame. It all depends on the design. Okay, so in the course of this lecture or in the course of starting the general arrangement, we start off by studying the architectural plan that has been provided. And like we have over here, we have the ground floor, we have the first floor, and we have the second floor. All right. So on the ground floor, you can see we have a lounge and we have two other rooms here, and we also have a mini room here, which is our visitors toilet. Okay, so on the first floor, we have a series of two bedroom. So this, with my observation, this part is what is replicated to this part as well, and is also similar to this part as well. Maybe there might be little or no changes. Okay, so this is what is going on internally on the structure. And also at the second floor, we have a series of two rooms and suites. Okay, so the next thing to study is your elevations. And when we are studying our elevations, what we are trying to observe is to know if we have any part that requires cantilevers on our structures. So we'll start off by the approach view or the front elevation. And if we look at the front elevation, you will see that moving away from the ground floor, which is this point, up to the first floor, you will see that we have an increment in size here. So this tells us we should be expecting to cater for a cantilever when we move from the ground floor up to the first floor. And if you observe with me, you will see that the first floor and the second floor, they are quite similar in the approach view arrangement. Okay, so this is for this part, and we move on to the next view. So this will be similar to this as well, so we should be expecting cantilevers here. Then also at the right elevation, you will see that we should be expecting a cantilever here, and we should also be expecting a cantilever at the right hand side. The only difference is this is larger, and the cantilever here is quite small, okay, or the length of this cantilever is smaller than the ones on the left hand side. So this will also be the same thing that will be replicated on the right hand side, is smaller cantilever here and the bigger cantilever here. So by studying this elevation, this automatically tells us that we should be expecting to design for a cantilever as earlier said. And if you come back to the ground floor plan, you will see the positions of our cantilever here, which is indicated by these lines, these dotted lines. So these dotted lines is trying to tell us that we should be expecting a cantilever at this position, okay, when we move from this ground floor up to this first floor. So as you can see over here, the cantilever does not cover the entire part of this structure. It has a recess at this part, and it also has, yeah, and it also has another recess at the right hand side. So these are some of the things you encounter as a structural designer, because you do not expect the architect to maintain the same thing from the ground floor to the first floor, or maintain the same first floor plan to the second floor plan. So there are chances there will be internal changes as well. Do not forget that what we've seen so far are only the external changes, okay? So there are chances that the wall lines here, or the positions of these walls, might shift when we move from the ground floor up to the first floor, or possibly when we move from the first floor up to the second floor as well, okay, because the architects are always trying to be innovative. They are always trying to meet up with the demands of the client, so you do not expect them to be complacent with their architectural plan. So with the field study we've made so far, let's head on to the general arrangement proper, okay. So to do this, I will create a copy of these three drawing, my ground floor, the first floor, and the second floor plan. I will create a copy from this point, okay. I will copy these three plans up to somewhere here. This is just so I do not tamper with the original architectural file. I can always make reference to this just in case I make any error on this very plan, okay. So as you can see, our plan is a bit clumsy, so I would prefer we take out some features that will not be required, just like these cars over here. So we'll just quickly delete this, and we'll quickly delete this as well. So we'll quickly delete this, and in order to see what is really going on in our structure, I would prefer we take out the dimensions that are already existing. In case we need any dimension, we can always choose to dimension them afresh, okay. So I will select three drawings, or firstly I will have to select this and look for the layer of this dimension. So this is under dimensions layer, okay. So I'll select all of this, and I will use my quick select tool. I'll use quick select, then I'll come to layer, and I will come to dimensions. I'll click OK, and I can delete my dimensions, okay. So this drawings becomes a bit clearer than it was, okay. And I can also choose to take out this hatch so it doesn't interfere with my grid lines. So if I select this, this is under let's see, if we come to the home tab, this is under a wall partition, okay. So we'll select these three, select everything here, come to quick select, and we'll come to layer. We'll look for a wall partitions, a wall parts, okay, and we are looking for hatch. All right, so we'll select this, and we can erase this, okay. So this becomes a bit clearer. So to begin our general arrangement, the first thing we need to do is pick some proposed column positions on our ground floor layout. Okay, so we're picking some proposed column positions, and before we do that, ensure you have a different layer that represents your column on your structure. So over here, if I come to my layer properties, I have I have two layers on this structure which you can also create for yourself. The first one is I prefer to have my column layer, okay, and the second one is my discontinuous layer. So as we work together, you get to see how these two layers become important. Okay, so I will come here and I will change this from dimension layer, and I will make my column layers active. So I'll make my columns layer active, and I will create a column with the dimensions of my block wall. Okay, so if I look at the dimension of my block wall, I have this from here to be 225, and I have here to be 225. Okay, so this part, I will come here to create a rectangular column of 225 by 225 millimeter, and I will hatch this. Okay, and the next step will be picking some proposed locations on this ground floor. So we're picking some proposed column locations with due regard to some general column guidelines or some general column principles. And the first of these principles is always to ensure our columns are placed in between walls, okay? So that during the construction phase of this project, our columns can always be hidden by the block walls. So let's say what we are trying to do is pick appropriate positions on the ground floor that we hold our columns. So we'll always try our possible best to ensure our columns are hidden in between these walls, so that during construction these block walls can as well hide our columns, which is different from when we have a column at this open area, okay, which is beneficial than when we have a column at this open area. So we'll try our possible best to always ensure our columns are hidden between walls. And another thing we'll be doing is, due to the fact that this is a simple residential structure, and to avoid overspanning beams, right? Because we'll be running our beams from column point to column point. So we'll also be trying our possible best to ensure the maximum spacing between our columns does not exceed 5 to 6 meters. And this is not because we cannot design beyond 5 to 6, 7, 8 meters, but just because this is a simple residential structures, and we are also trying to avoid overspanning beams with a lot of reinforcement, okay, because longer spanning beams will lead to larger deflection, and this will lead to providing higher concrete sections and probably higher reinforcement. So we'll try our possible best to limit the spans of our beams, or to limit the spacing between our columns to about 5 to 6 meters. Okay, so let me take out these border lines, select this, and also select this, and I can erase. All right, then I will pick this column, and I will start picking my proposed column positions. Okay, so the first proposed column position should be this angle over here, which is the edge of our structure, and the second proposed column location should be the demarcation between this structure and this apartment and this other apartment. So let's put a column here. Okay, the next proposed location should be this point. Okay, while the next proposed location should be at this angle over here. All right, then we move on to the next grid line. Let's move from grid line 1 to grid line 2, and the best possible proposed column location should be this point over here. Okay, while the next proposed column location should be this point, and we'll also drop another column here. So keep in mind that this is not our final column positions. Okay, we are trying, this is still a proposed column positions. There are chances we might get to make modifications to what we are doing here at this very point in time. Okay, So moving downward, due to the fact that we have a staircase here, okay, I will put a column at this location, because during the construction of our staircase there are possibilities, or we'll get to run a beam from this column to this column, because we'll get to anchor our stair slab or our staircase beams into these other beams that connect from this column point to this column point. So we need to put a column here, and we also need to put a column in between these two staircases so it can hold our staircase beams. Okay, then we'll use the same line to put a column at this left hand side, and we use that same line to put a column at this right hand side. Okay, so the next proposed column locations lies between this point and this point. Okay, it also lies between this point and this point, but this will be my favorable location to put my columns. So the reason I picked this extruded part of the wall over this corner here is because if you observe here, we have an indication of cantilever as we've earlier studied. So it means if I get to put this column at this position, okay, will be expected to support this cantilever with this very column. Okay, and the distance from this point to the end of this cantilever is about 2.5 meters. Okay, it can actually be designed for, but if we go with the second option, which is this point, if we go with the second option here, the distance from this column to, and let's see this in the picture. Okay, so against putting our column at this corner here, we've shifted our column to somewhere here. Okay, so the distance from here to here in order to support this cantilever will be longer, and this will lead to providing a thicker sections and might even require more reinforcement. So it is better we push our column to somewhere in between this wall so we can have a lesser length of cantilever. Okay, and this does not affect the aesthetics of the structure. It does not affect any other thing structurally. So we'll prefer picking this point as our proposed column locations. So we'll come here and let's erase this dimension. Okay, so I will also transfer this column from this point. Let me copy this from here, and I will put it at this corner over here. So I will prefer to put this here over this point, because from this point as well, if we choose to dimension from here to the end of this other cantilever, then we are having about 3.1 meters. Wow. Okay, so it is better we have from this other point, this other grid line, to this point, which is just about 2 meters at maximum. Okay, so I will do the same thing for the middle structure, but the difference is in this case I will put a column at the end of this toilet area, and I'll also put a column at this part. Okay, and the next is I'll put this column at this end. All right, so this becomes my first proposed ground floor column locations. So let's go ahead and study the distance, or let's study the length between our column points. So if I come here to dimension this from this column point to this column point, if I come here to dimension this, I have about 5.765 millimeters, which is approximately 5.8 millimeters. And on moving to the first floor, we shall also be having a cantilever here. So this is getting to about 6.5 meters. So I prefer we reduce the space between these two columns, and the most I will prefer we reduce the spacings between these columns, not to overload them. Okay, so the best position to introduce a new column will be at this store area. So I will select this, and I will copy from this location up to this location. Okay, and I'll also do the same thing here. Let's do the same thing here to cut the span between this column and this column. Okay, so let's check this as well. This should, we should be having, this is almost the same thing. So this is 5755 millimeter. Okay, and from this column point to this column point as well, we have 5.755 as well. So I will do the same thing we did for the left hand side. I will copy this column from this point up to this store area. Okay, and I will copy this from here to here as well, and I'll also demarcate this long spanning column spaces. Okay, so this becomes my first proposed column location. Then this, from this point to this point, should also have the same distance. So I will break this off by introducing a new column. Also considering the fact that we have a cantilever on the left hand side, I will take my new column location to this point. Okay, and I'll also break this up by taking my column location to this point. Okay, so the same thing works for this point and this. So I'll put my column in between this point, and for this case I'll also put my column in between this point. Okay, so I have a limited spacing, and let's check the distances. From here to here I have 1725, and from this point to this point I have about 4 meters. Okay, this is okay, and we should be having almost the same value here. Same, almost the same value, and from this last span we should be having same thing. Okay, so let's check the horizontal distances between our columns as well. If I dimension this, I should have this to this as 2 point, almost 2.5 meters. And let's check this, this should be longer. From here to this point, okay, I have just about 4.2 meters, which is very much okay. Okay, from this point to this point I should have about we should have approximately 2 meters. So the column spaces on the vertical direction are actually satisfactory. Okay, so this becomes my proposed column positions on the ground floor. Okay, so after picking these proposed column locations, or for better understanding, let's take a look at the section. Okay, so let's say what we have done so far. Let's take the sections of this wall as our columns. Okay, so what we have done so far is we have picked the proposed column locations on this ground floor. Okay, we have picked these proposed column locations, so we need to superimpose this on the first floor to see if these proposed column locations can be continued on this first floor, and possibly it can also be continued on the second floor. Or it could be that by the time, okay, yeah, or it could be that by the time we pick these proposed column positions and we'll try to move it to the first floor, just in this case here, you will see that if we try to maintain this very column position from this point to this point, you will see that it will be directly in this bedroom area. Okay, so in cases like this you can now look for how to transfer this column to other positions, okay, on the first floor. But first we need to observe the interaction between our proposed column on the ground floor with the first floor when we superimpose. Okay, so I will come to the plan view, and I will create a different copy of this first floor layout. I will copy from here up to this point. Okay, and let me Let me take this out. And let me take this out as well. Select this, and we can take this out. Okay. So what I need to do is I will pick these columns and put them on the first floor to observe their interaction. So permit me to come to view, and let me divide these two screen. Let me divide this drawing into two different screen. So my ground floor layout will come here, and my new first floor plan will come here. So I will select everything here, and I will use the quick select tool, and I'll be selecting my columns. Okay, and I'll copy my columns from the intersection between grid line G over here and grid line 2, which is at the mid of this staircase. So I'll copy from here, and I'll come here to place this. Okay, so let's observe this interaction. Okay, so as you can see, we have our column exposed in this bedroom area. Okay, so these are some of the challenges you get to encounter as a structural engineer. These are some of the challenges you get to encounter as a designer. So you have to, this is where your experience, this is where your dexterity comes in, and this is where you get to solve issues as a structural engineer. So carefully, let's observe what is going on the first floor. We have this column exposed in the bedroom. This column will be exposed in the bedroom as well. This will come out in the bedroom. This will come out in the bedroom. Okay, this will be hidden in between walls, so this is okay. This will be hidden in between walls. This is okay. This will be exposed. This will be hidden in between walls. This will be hidden, exposed, and hidden. Okay, so this will be exposed. This will be exposed. This will be exposed as well. We have some hidden columns here. So basically, the most or the safest columns are the ones in between our demarcations. Okay, the ones that demarcate each of these structures from each other, which are these wall lines. Okay, so this is the safest grid we have so far, grid D, and the next safe grid we have from exposed areas are the line on grid line G. Okay, so these columns here, let's work together to see how we can solve a lot of these issues. So some cases there is nothing we can do. We can only try to redistribute this column when we get to the first floor, thereby terminating them at the ground floor. Or there are some cases where we can also make modifications to these arrangements. Okay, so permit me to divide my screen, and I will take the ground floor structure to the left hand side, and let me take the first floor structure to the right hand side. So let's see if we can make further modifications to this ground floor layout in order to avoid a lot of these columns, okay, exposed into these open areas. So the exposure is not really the issue. What we are trying to avoid is shifting our columns from different positions to the other, because our columns are stronger when we are able to maintain the same position from the ground floor up to the first, second, and depends on the numbers of stories. So our columns are more stable when they are at a specific position, okay, on each of the floors. So it is better than always trying to shift your column positions from one point to the other to fit into the structural arrangement. So if you observe this first column here, this is the column at the corner, which also is this column at this corner here. Okay, so for this there is basically little or less we can do here. This column has to be here. The only thing we can do when we get to the first floor is to redistribute it to other positions for support. But for this column, there is basically nothing we can do at this very point. Okay, so we have to keep this. Now moving on to the next column on grid line B. Okay, if you observe the next column on grid line B, so remember that the reason we introduced this column was to break the length between this column and this column. Okay, so against having my column at this very position, which is on this grid line B, I would prefer we transfer this column to this very position, okay, from the ground floor, so it can become a continuous column just like we have over here on grid line D. So we don't it doesn't necessarily have to come out at this bedroom area. Okay, so if we look for a way to still bury this in between walls starting from the ground floor, then we can use one stone to kill two birds. Okay, so I will have to create a grid line. Let me create a vertical grid line in between this wall and this wall. Okay, so let me trim this. Let me trim this, and let me also put this at the boundary. So I'll select this, and I'll trim this top. I'll trim this part, and I'll so let me match this to this. Let me match this to this, and this will be grid line. Let me rename this to grid line B asterisk. Okay, all right, so I can copy this from here to from grid line C, and let me copy to this point. Okay, so we can we've also encountered another issue here, which is our window position. Okay, so we can discuss with the architect, we can discuss with the architectural team to kindly help us move this uh window position from here to somewhere here, just about 300 millimeter. Okay, in order to have this place for our columns. Okay, so in order to have this column starting from the ground floor, so what you should keep in mind that this verdict is not finally up to you. You must always have to discuss with the other counterparts that are involved in this project. You, not because you're the structural engineer means you have to take all of these critical decisions all by yourself. You always have to discuss with the team because they've put in effort to arrive at this result. So just making these changes without informing them, it doesn't really speak much of you as a team player. Okay, so I'll to demarcate the length of our columns, we'll have to move this from this grid line onto this new grid line. Okay, so I'll prefer starting this from my ground floor. So when we get to the first floor, the new column will still be here somewhere around this position, and the other column will still be at this very location. Okay, so this is the first modification I'll be making on the ground floor. And like I said earlier, this is not our final ground floor plan yet. As we are still making observations, there are chances we might still get to make modification to this until we arrive at the final ground floor layout. Okay, so this is okay. Then we'll move on to the next grid line. So the next grid line is grid line D. This is okay. So for this, let's observe if we can make modifications to this from the ground floor as well. If we come to grid line E, okay, so if we come to grid line E, there's probably nothing we can do at this very point, because if we decide to move this just even 50 millimeter to the left hand side, then we are going into this entrance, or we are also covering up this place. Okay, so I will leave this as it is on the first floor, and when we get to the first floor structural arrangement, we'll get to redistribute this column from these positions to other suitable positions. Okay, so grid line G is okay, and let's also look at this on grid line I. So if we come here, as you can see, if you also try to move this from here to this point, you will see that we'll be interfering with this entrance as well. So we'll better leave this as it is. So if you come to the next, for this corner columns, there is pretty much nothing we can do at this very point in time. And let's move downward. And I just made an observation over here. Okay, I just made an observation at this very point. So if we come to the left hand side, you will see that we have a recess here. Okay, so against putting this column at this very position, which is here, against putting this column here at this point, that when we move to the first floor, it becomes exposed into this bedroom area. Why don't we push this column from here on the ground floor to this point? Okay, to somewhere around there. So when we get to the first floor, this column will still maintain its position around this very point. Okay, so this is an option we can exploit. And to do this, I will have to create a horizontal grid line. I think this is a better option. Okay, or what we can do is for this right hand side, okay, we will start this column from this position on the ground floor. So when we get to the first floor, we can maintain the same column positions from the ground to the first. Okay, while on the left hand side, we can leave this at the initial position. So we also get to observe, or we also get to learn how we can solve issues like this, because not in every cases we are going to have this recess. Sometimes you can have what, a full flare cantilever. Okay, we can have a full flare cantilever, so we will not be able to move this column from this point up to this point. So in cases like this, what can be the solutions we can prefer, or how can we go about solving these issues? So it's more like using one stone to also kill two birds in this scenario. So for this left hand side, we will leave this as it is, while for this right hand side over here, we will move these column positions to this place. Okay, so permit me to draw a horizontal grid line at the middle between these 2 points, this and this. And again, I will draw at the mid between this point and this point. Okay, so I will align this with this, and also align with this. I can select these two, and I trim the extrude of my grid line, and let me erase this and match these properties of this point up to this point. Okay, so on the ground floor, I'll copy this two beams, these two grid lines rather, and I'll copy from this intersection, and I'll put them at this intersection. Okay, so it automatically aligns with this position. So what I can do is move this column from this position all the way down to this part, and I can move this from this previous column position all the way from here onto this part. Okay, so when we get to the first floor, it automatically comes out at this position, and we can have what, a continuous column. So some other persons might also prefer to use this same approach both on the right hand side and on the left hand side, just to keep the columns at the same position. But one thing you should understand is that as structural engineers, your general arrangement might be a bit different from mine, and it doesn't mean mine is 100% correct or yours is wrong. Okay, so it all depends on how we intend to connect these members to have a safe, sound, and robust structure. So let's go ahead and check the distances between these two columns. So since we've already made modification to the previous length, so if we check from here to here, we have just about 4 meters, and if we even add the cantilever, this cantilever, we have just about 4.5 meters. So the span of this column is actually very much okay. And let's see for this as well. from here to the end of this cantilever. We also have just about 4.5 meters. So the span of these column points are actually okay. Okay. So we'll move on from here to this part, and this will be exposed in the column area. So we'll look at how we can deal with these issues since we are not moving this from this position onto this position. Okay. So this is still hidden between walls. This is still hidden between walls. The only issue is interacting with this window. So while we are making our first floor structural arrangement, we'll take note of this and we'll make modifications to this column. So for this is all between walls. This is between walls as well. This is this will no longer be exposed. This column here, which is this, will no longer be exposed due to this new arrangement. So let's delete the previous columns. Let's select this, come to quick select, come to layer, come to columns, and let's erase the previous columns. So let's copy this new column from this position onto and copy it back to the first floor plan. Okay, so come to layer and come to columns, and we'll copy from intersection between 1 and A. So we'll copy from here and we'll come here to this point. Okay, so this becomes my new proposed, this becomes the new location. So as you can see, when we move from the ground floor to the first floor, these columns is still a continuous column. So like I said earlier, columns like this and this, there is pretty much nothing we can do about them at this very stage. So the next stage we'll be going into now will be creating our beam structural arrangement, which will lead us to creating what our first floor structural arrangement. So when we talk about, and that is the only thing that will help us to solve these issues of the column interfering or coming out at this bedroom area. And to further understand this first floor structural arrangement, if we look at a section, okay, let's take a look at this section here. Okay, let's cut a section through this point. If you are talking about your first floor structural plan, we are actually referring to this part over here. Okay, so a comprehensive first floor plan or a comprehensive first floor structural plan should be able to guide you or show you the columns that are coming from the ground floor, because some of these columns can be continuous, some of them can be discontinuous. Okay, then it should be able to also show you the beams that will be running on these columns. Okay, because there will be beams running on these columns. Then it should also be showing you your slab partitions. Okay, the slab partitions on this structure, and at the same time it should be able to show you the columns that will be present on the first floor. Okay, so the usefulness of the columns coming from the ground floor is, like I said, we can have some discontinuous columns. So when you are constructing on site and you have your first floor structural plan, you'll be able to see the columns that are coming from the ground floor. Some will terminate and some will continue. You will also be able to, just looking at the first floor structural plan, you also be able to see how those beams are connected on the columns, or they are connected on different beams. Okay, because we can have beam to beam connections or beam to column connections. Okay, and also show you your slab panels and your slab partitions. Then it should give you guidance on where you are to put your starter bars that will start your first floor columns. Okay, so this is the importance of your first floor structural arrangement. And I think to understand this better, I would quickly make a Revit structural plan so we can grasp the concept of this first floor structural arrangement. So I think I'll make this just after this video, and I can attach them in between the videos. Okay, so we can probably understand what we are talking about. Okay, so this is the Revit structural model. We have the Revit structural model here. Okay, like I said during the video, so we'll be attaching this uh, to the tutorial and some other points where we might be leading them going forward. Okay, so if we come to our first floor, this is our first floor. So when we speak about our first floor structural layout, like I said earlier, it should be able to show you your columns. Okay, taking a section through that point should be able to show you your columns coming from the ground floor, then the beam structural arrangement that will be on these columns, then your slab and your slab partitions, and also give you guidance for the columns that will start from the first floor. So while you are constructing this beam and these slabs, you can as well insert your starter bars that will receive these columns on the first floor. Okay, so this is the idea about your first floor structural arrangement. So this is now the solution, or this is how we can provide solutions to the columns that will be exposed to our bedroom area when we move from the ground floor to the first floor. Okay, so now let's move on to making our first floor structural arrangement. Okay, so we'll be working with this over here. We'll be working with this first floor plan with the columns that are coming from the ground floor. And one more thing we'll be doing is we'll copy this floor plan, the first floor plan. We'll copy it from this position here onto, let's copy it to somewhere here, and we'll select everything here. Okay, everything, and let's take everything here to be a red color. Okay, let's take everything here as a red color, and we'll also copy this ground floor plan. We'll make this copy to somewhere here, and let's put everything on the ground floor. Let's change the color from this part to a blue color. Okay, let's change everything to a blue color. So what I will do is I will superimpose this ground floor on the first floor, or I can superimpose the first floor on the ground floor, whichever the case may be. So I will select this, come to clipboard, and I will copy with a base point. Okay, my base point will be the intersection between grid line 1 and grid line A. So I will copy from here. Then I will come back to clipboard and I will paste this as a block. Okay, so let me paste this as a block, and I will paste on, and I will paste on this intersection between grid line 1 and grid line A. Alright, so let me erase this, and now we can clearly see the difference between what is going on the ground floor, which is in the blue color, and what is going on the first floor, which is what our red colors. Okay, so permit me to divide this screen again. I will come here, come to viewports configuration, and divide the screen, and I will put this superimposition here while I start working on my first floor structural layout. So now we already have what our columns that are coming from the ground floor. So the next thing we need to impute are the beams that will be running on these columns. Okay, and our beams we run on what, the walls that are on the ground floor. So preferably we'll always get to run our beams, or let's, to understand this better, let's come here. Okay, so let's say we have our columns at this position. Okay, we'll have the columns at these different positions, so it will be better we run a beam on this ground floor walls. Okay, so okay, so you can also use this picture if it speaks volumes. Let's go back to this. I think this is better. So let's say we have this, what we have, beams, we have columns at this respective position. So if we want to run our beams, it is better we run our beams on these walls. Okay, so this wall can also cover up those beams and they don't become exposed at the living areas or any other areas on the structure. Okay, so looking at this plan, do not forget that the blue is our ground floor. So we'll be running, firstly we'll be running our perimeter beams. Okay, so our perimeter beams we run from this grid up to this grid and we'll be running on our ground floor walls. So if we come back to our ground floor plan, which is this, so we'll be running a beam on this wall from this point, grid line A, up to this point, which is grid line J. Okay, so we'll just create a copy of this wall to represent our beams. Let's copy this from here, so it will run on this wall here. So we run from grid line A, that's our first beam, our first perimeter beam. So we run from this point, from here up to this point, which is grid line J. So we can select this and we can extend to this point. Okay, so this becomes what, our first perimeter beam. Okay, so we'll be coming back to making all these modifications, but first let's have what, our perimeter beams. So the next we'll be running from grid line 1 up to grid line 5. Okay, and it will be running on these ground floor walls. So this, which is at the same position as this point here, so this will run from grid line 1, this will run here, this beam will run on this part. Okay, and it will also run to this grid line 5. Okay, also run to this column here. So we extend this from here to this point and this to this point. Okay, so let's also run this other perimeter beam over here. So we'll run a beam from this position up to this position. Okay, so the beam will be running, remember we dropped a column here, somewhere here and somewhere here. So the beam will be running at this point up to the edge of this toilet area, continue from this toilet area from this point to this point. But the beam will be hidden by these finishes. Okay, so we'll come back to the AutoCAD plan and we'll select this and this, and we can copy. So this will run from here to come here, and we can trim this out. Okay, so the perimeter beam will run from this point up on this toilet area until the end of this grid line. So extend this here and extend this here to this part, and the last perimeter beam or surrounding beam will have to run on this part. Okay, let's erase this and this, then we'll select this and we'll extend this to this point, and we'll also select this as well and we'll extend from this point to this point, and we'll also extend this. Okay, so now we have what, our first set of beams running on this part, running here, running this part, and also running on this part. So with these beams we can solve the issues that we have with what, these columns. Okay, let me take out this facade here, let me take this out and also take this out on the, okay, it has gone out. So from this point we can now solve these issues that are related to these specific columns. Let's mark out the columns we intend to discontinue on the when getting to the first floor. So that will lead me to launching my discontinuous layer. I'll come here to discontinuous. So earlier on we said this column will be a discontinuous column because it's exposed in this living area. Okay, we also said this column will also be what? A discontinuous column. We said this is okay, this is okay, this is hidden between walls as well. This should be a discontinuous column. On the first floor is actually in this toilet area. Okay, this also is a discontinuous column. This is a discontinuous column as well, coupled with this. Okay, this can be continuous if we wish to. This can be continuous. It can also be discontinuous because we can choose to negotiate with the architect to move this toilet to the left, to the right hand side. Okay, but this possibly should be discontinuous. We'll get to see if there are other issues that will lead us to making this column a discontinuous column. Okay, but for now it is still hidden between walls, so we can still leave it as it is. So we'll come to this, and the next discontinuous columns we have are this one and this one. Okay, so let's start solving one of these issues after the other. Okay, so to solve this issue of discontinuous column, what we need to do is, on the first floor, is we need to cantilever this beam that is running across this place, okay, on the ground floor. So we cantilever this part out to the end of this, and we can redistribute this column from this point up to this point. Okay, and we also do the same thing going to the left hand side. We extend this beam which is running from the ground floor up to this end, and we can in turn support the new columns that will carry our first floor with this cantilevered beam. So to understand this better, I think I have a picture that speaks to that, and let's see. Okay, so this is similar to the very situation we are talking about. So we have this column coming from the ground floor, and if we continue this column on the first floor, it will be exposed to this living area or somewhere at this open area on the first floor. So what we've done is we've run these perimeter beams on the ground floor, which is this and also this. So to provide a solution to this situation, what we can do is, when we get to this end, we can extend this beam beyond this point. Okay, so the cantilever comes from this part, or the beam comes from this part to this joint and cantilevers outward. So from this point of the cantilever, we can now choose to support this with a column. Okay, so we can now choose to support this part with a column. So this is the same principle we'll be adopting here. So we'll come back to our AutoCAD plan, and from here we'll extend a cantilever from beyond this column position to this point. Okay, and firstly, let's create some grid lines. Okay, let's create grid lines at all these positions between these newly introduced walls. Okay, this will just take a few seconds. Let's create some grid lines. So we'll create horizontal grid line. I will create this between this point and this point. This is the first, and let's look at other positions that we might need grid lines as well. So due to this new cantilever, we should also be needing a grid line between these two walls. Okay, and let's see if we have other new introduced horizontal walls. Let's see. Okay, I think we have just these two, and the next point will be the vertical walls. Okay, so we should have it at the middle of these 2 points. Okay, we should also have to match this part. I will match this part. Okay, so we can redistribute this column from this position to this position, as we earlier said, and we can also send the cantilever out from this beam running on the ground floor outward. Okay, so if we choose to run this beam to this point, you will see that it interferes with this window. But this can also be discussed with the architect, or what we can do is we can simply just decide to run a beam. Okay, so if we intend to run a column here, so it means we have to discuss with the architect. But if our plan is just to run a beam, then we don't necessarily need to discuss anything, because the beam and the windows are not on the same level. Okay, so I will join this and this together to indicate a beam, and let me extend this beam beyond this cantilever point calling point to make them a cantilever. Okay, so this will now move from here to this point, and it also move to this point. Okay, so this now becomes what my discontinuous column. So this becomes the discontinuous column. Okay, so this is how we can solve this issue, and yeah, this is how we can solve this issue. So we'll do the same thing for this top side, right? We'll extend the cantilever from this point of the column, beyond this point of the column to this point, and we can transfer this column. Okay, we also run the cantilever from here up to this point. Okay, so we can transfer this column from here to here, and also transfer to this point. Okay, so I can come here, erase this, then I match the properties of the discontinuous layer with my discontinuous column. But there's something I have observed at this top part. Okay, so what you should know is that these double lines indicates we are putting a beam at this end. Okay, just like we have in this picture here. So it indicates we are putting a beam at this end. But if we carefully look at the distance from this beam to this beam, you will see that we have just a space of about 75 mm in between. So this space will be too small for our slab. Okay, so for this top side, and let's compare this to this down part. So for this down part, we have about uh we have about 1.1 meter. Okay, so this is actually suitable. We can have our slabs at this point in between this beam and these governing beams. Okay, in between this part, in between this parts and this new governing beams, so we can have this space for our slab. But for the top side, due to the short length of this cantilever, I will prefer we just run this beam as a cantilever from this point to this point, and we don't necessarily need to cover it up with another beam. Okay, so we can design this part over here. We can just design them as a slab. Okay, we can just design them as a slab, so we don't necessarily need to have double lines to make it act like another beam is covering this part. So the only cantilever will be this beam. And to understand this better, I think I also have to create this on a Revit model. So we are doing all this because structural engineering is a serious business. You are dealing with life and properties. So if we are to say something, it's better we'll say it and we'll make it clear, because you understand that some ideas might be borrowed from here to make decisions while you are designing your own personal structures. We'll try our best to always keep to our own path of integrity. Okay, to always ensure that whatever we are saying out becomes as clear as possible. So if I come to the Revit model, okay, and I come to my first floor layout, so my explanation is, if we look at this part, here, okay, we have enough space between this beam here and this beam in order to have our slab. But if we intend to use the same style here and we try to put another beam at the end of this slab, okay, we'll have just about 75 millimeter around this point. We'll have just about 75 millimeter around this point. Okay, so this beam will take a lot of the space. So what we can do is only send out a cantilever directly, just send out a beam as a cantilever, then the rest part of this can be designed as a cantilevered slab. Okay, not necessarily a cantilevered slab because we have a beam at this end, we also have a beam at this end, and have a beam at this end, but I believe you get the concept of what I mean. So we'll minimize this and we'll come back to the AutoCAD plan. So we can deliver this part out, and let's trim this, or let's extend this to, let's join this and let's join this. Okay, so we'll also do the same thing here. We'll extend this part of the beam, we'll run the beam here and extend this to this part, to this part. Okay, and carefully observing this part. So the truth is we actually need this beam to run from this point to this point, because this is what will help us to demarcate our stair area from our living area. Okay, so in essence, if we come back to the ground floor plan, this beam will run all the way from this point to this point, and it will differentiate, it will be the beam that will differentiate this staircase part from this living area. Everything we are doing, we are trying our possible best to keep beams away from this open area on the ground floor. So when they get to sit at this lounge area, they will not be see beams running all across this part. Okay, but for this other point here, it is okay because it is the demarcation between the living area and the staircase area. So we'll run this beam directly from here up until this cantilevered part here. So I will select this and as my boundary, and I will extend a beam directly from this point to this point. Okay, so this is the beam that runs all through this point to this cantilever. But you can see we have less support here. We have on this beam, we only have a support here, and we only have a support here. So along the line, we'll get to see how we can profile other supports in order to limit the span of this very beam. Okay, so for now we have this issue sorted. So we'll get to move this column from this point, from here up to this point, and this now becomes what, a discontinuous column. Okay, so I can match this with my red here, which indicates this to be my discontinuous column. Okay, so one thing is the modification we've made here, or let's say we can make the modification to this left hand side, and we'll take the idea, or we'll copy the idea that we have, or that we've made on this left hand side, then we use that same idea to work on this mid part and also work on this right hand side since they are similar. Okay, so I will also send a cantilever from here to the end of this slab. I will send this here, and I'll be sending my column from this point. Okay, this column will terminate at the ground floor, and this column will start on this beam, sorry, to start on this beam on the first floor. Okay, so let's select this and we match this. So what we have done so far, if we come to the Revit structural model, what we have done so far is just sending this beam from this column to this point, and on the first floor we are now having a new column starting on the cantilevered beam. Same thing as this point, sending the beam directly outside, and from that cantilevered beam, we can now have our column resting on this, while this and this becomes what, the discontinuous column that stops on the ground floor. Okay, so let's come back to our AutoCAD plan. So the next position where we need to run our beam will be on this wall over here, will be on this ground floor wall over here. Okay, so that's to say our next beam will run directly from on grid line 2. So it will be running on this wall. Do not forget this is our ground floor, so it will be running on the ground floor wall. Okay, so the next position of our beam will run here, will run here to here. Okay, then we can erase this part. Let's erase this part. And we cannot use this as our beam position. Okay, we cannot use this point as our beam position, because if we run a beam here, which is this cantilevered area, if we try to run a beam here, by the time they sit, let's say we have a beam here, by the time they are sitting at this place, no, this beam will be exposed. There will be a drop down of this beam. If you are using 450 millimeter and our slab is 150 millimeters, if you are using a 450 millimeter thick beam and our slab is about 150 millimeter, so there will be about 300 millimeter drop down. Okay, so that is why we are prioritizing running our beams on this ground floor walls. Okay, so let me erase this, and this becomes my beam position. I can erase this and trim this out. Okay, let's trim this out, and let's also trim this out. Okay, so from this beam we can choose to have a small cantilever. All right, but I will send a cantilever from this ground floor wall outside in order to receive what, our first floor. Okay, so I will send a cantilever to this point from here. Let's explode this, and okay, so this window will have to give us, or we will have to discuss this with the architect as well. So let's say about 75 millimeters. So this is not actually much, 75, or let's say 100 millimeter. So just about 100 millimeter. Okay, so we'll extend this here, and we can extend our beam from that point to this point. Okay, so let me erase this window. Let me erase this window here, and to remove this column in red circle, I will have to transfer this from this position to this part here. Okay, and one more thing, I'll also transfer this beam, I'll also transfer this column from this position up to this position. Okay, so this now becomes my discontinuous. Can now match this with this. Okay, so the main part of the support will be coming from this part. Do not forget that we can also choose to just run this as just run this beam here, while this other part we can just choose to design this part as a cantilevered slab. Okay, we don't necessarily need to add what, our beams at this end. And the reason why I'm saying so is our cantilevers are always stronger when they run at a distance, or when they have a tie back. Okay, so we have this beam already running from here, so the reinforcement that comes from this beam is what we cantilever straight outside to receive this column. But for this case, we have the beam coming directly from just this column area. It doesn't have any tie back. This doesn't mean it wouldn't work, but structurally a situation like this is actually preferred. Okay, and if it is not carrying any load on the first floor and other suspended floor, I would just prefer we also cover the edge with a beam. So let's extend this out. let's extend this out to have a beam. Okay, so we can offset a distance of 225 millimeter, and we can close this up. Okay, so this becomes what the part that will receive the slab, why we have this as the beam that covers the edge of our slab. So we'll solve this issue, okay. Let's take this circle out. We've also solved this, and the next will be this one. Okay, so the best possible thing we can do here is to also run a beam across this point. And mind you, this will not be seen when you are at the living area, because this is more like the demarcation between, we have an extruded wall here, so this is more like a demarcation. Okay, so we can run a beam directly on grid line 3, and let's say grid line 3, which is this point. So we'll select this, and we'll run a beam. What you should know is, if you are running just a beam and we do not intend to include a column here, okay, we don't necessarily need to worry about this window. Okay, because we will have something like this. We are just running a beam. But in cases where we still intend to put a column, is where we should be worried about shifting the window position to the left or to the right to accommodate the new structural arrangements. So I'm not worried about this, but I just need to erase it. And my preferred new column location will be taking this column from this point, from here, okay, up to this point. So this is my own preferred location, so I don't necessarily need to worry about the window. Okay, so I can join this together, and I extend this beam from here up to this point. So this is to help us have a rigid frame. Okay, so I join these two, and I take this out. Then I can now match the properties of this to this. Okay, so as you can see, we've solved all these issues. Okay, so let me trim out this part. Remember, we are not running a beam here, so it doesn't get exposed to this column area. So I will trim this, and I'll trim this part out. Okay, so this becomes a small cantilevered slab section. This is the cantilever slab section. This is another slab panel. Sorry, this is another slab panel. This is one slab panel. This is another one. We have a smaller one here. Panel, 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 and panel. Okay, so like I said earlier, we shall be providing support for this long beam. Okay, so the support we'll be providing is, if we put this, let's take this to a single screen. I will put this here. Okay, let's put this here. I will put the here, and I can put my Revit model at this right hand side. Okay, so let me drag this. Let's drag this boundary a bit. Okay, so remember I said we'll be looking for ways to support this beam, because this beam is very long to be without a support. Okay, to be without some intermediate support. So what we've actually done here has provided a solution to that issue. Okay, so if we let's come to this part on the Revit model, and let's understand both drawings together. So let me just take out this slab. Okay, so if I take out this slab on grid line 5 here, I have this red discontinuous column, which is this at this very point. Okay, and it cantilevers out to receive this very column over here. So which cantilevers out to receive this very column, and cantilevers downward to receive this very column. Okay, which cantilevers downward to receive this column, and it becomes discontinuous and which is why it is in red. Okay, so for this other beam, it is supported by this column and this column. Okay, so as you can see over here, we have a beam running across this point. So we have a beam running from this column point up to this column point. Okay, so this is the column, and this column is what is carrying this beam. This is the primary beam. Okay, so on this primary beam, we can now have this beam resting on this primary beam, and from this place where we have this beam, we can now have this other column that is starting on the first floor. And the reason why we are pushing this column from this initial position, which is pushing this from here to this point, okay, is because it interferes with this window position, and we will try to manage this very situation. Okay, so that's to say we've broken this long beam at this point. Okay, because the same situation is occurring here. We'll have this column and this column as our main columns, while this beam is the primary beam that runs from this column to this column, and this beam can rest on this other one which runs here as a secondary beam. So in essence, we have a column here and a column here, and the beam runs from this column to this column, while this other beam can now rest on this as a secondary beam. So at that point of rest is where we now introduce what a new column. Okay, so we can make this column to align with this, and let's move this from here to here. We erase this and we can match this from here up until this point. Okay, so this now becomes our new first floor arrangement. So we copying this idea. As you can see, we've been able to solve all of these issues. This part over here is this. Okay, the main support is this column and this column. Okay, which is this and this, which becomes discontinuous. But coming to the first floor, we now have what our beam, our new our new columns resting on this point and also on this point, which is this and this. This is now the cantilevered part of our beams to receive what the first floor slab. So let's bring back our first floor slab. Okay, so I believe we've been able to do justice with one part of this structure, and because of this we can replicate the same idea to this mid part and also to the right hand side. Okay, so due to time, we'll be trying to do this as fast as possible. So we've been able to provide the structural arrangement for the mid part and for the right hand side, making proper reference to what we've been able to do on the left hand side. Okay, so just like we did over here, we have this part as or let's divide the screen. Let's divide the screen and let's leave our first floor layout here, and we'll come to our ground floor. Okay, so for this mid part, okay, this part becomes one panel. This store part here becomes another panel. Okay, so this part is another panel that passed through this point, that which is this becomes another panel, which is the sitting area, and also this demarcation here, this part here becomes another slab panel. Okay, we are making proper consideration and reference to what has been done on the left hand side. So we just use that idea to work on this. And for our columns that were interfering with our window position on the first floor toilet areas, so we also move them to align with these straight beams. Okay, also move them to align with these straight beams, which will be resting as a secondary beam on this column and this column, just like we explained earlier. So we also did the same thing to the right hand side, and we distributed the column to this part. Okay, why this the good thing about this part is we have this starting off at the ground floor and it also goes up to the first floor. It is not like this case where we had something different on the ground floor and we had to push this to this part in order to have what our first floor column. So for this we have the same column from the ground floor to the first floor. So which method do you think you prefer? I will appreciate if you can leave a suggestion in the comment box, or if there are anything you felt we could have done differently, you can always send us a mail, or you can always leave it in the comment box or on the chat box. We'll always do our possible best to learn from you as well and also to respond. The idea is how we can work together, how we can grow together as structural engineers and embroaden our knowledge. Okay, so this will be my adopted first floor plan. This will be the first floor plan. And one other thing I would like to add to this plan is on this cantilever. Okay, I would like to create a column here. Let me add a column to this point to rest on this cantilevered beam. Okay, and also add a column to this point or all these edges. So I'll draw from here to here. Okay, and I can also add this to this cantilever. So let me copy from here, add this to here, to this midpoint, and also add this to this midpoint. Okay, so I can use this as a perimeter beam. Let me use this as a perimeter beam, and I can select this and no, I can select this and this as well. Then I can run a beam straight from this column to this column to this, all over this part. Okay, and the rest part of this can be designed with a cantilever slab. This rest part here can be designed as what, a little cantilever slab, same as this part. Okay, so this becomes what, my first floor structural arrangement. And if you found this video helpful at any point, do not forget to like it, subscribe to our channel, and turn on the notification bell so you get notified anytime we post new videos on our channel. So what I need to do is prepare my second floor structural arrangement, and this will take a few seconds considering the fact that we already have our first floor plan and our second floor plan as almost identical. Yeah, they are identical. So what I will do is I'll come to single. Okay, and I will copy my second floor plan. Let me copy this to this point. Okay, and let me erase this as well. I can erase this, and I can also erase this. Okay, so the next point will be using our quick select. Let's come to quick select and let's come to layer. We are copying from our column layer. Select column. Okay, we'll copy at A and 1. So we'll select A and 1. We'll come here and we'll also drop it at A and 1. Okay, so let's observe if there are any changes. So as you can see, all our columns are in their respective positions, all hidden in between walls. Okay, so this makes our job very easy. So what we just need to do is to copy these additional grids that we've not given any name yet. So we'll copy this. Okay, we'll copy this. We'll also copy B asterisk because it's a new grid. We'll copy this. We'll select this and this as well. Then we can copy from the interaction between 1 and A, which is this point, and we can add those grid lines to our second floor plan. Okay, so let's add that to this point. So the next thing will be making what our second floor structural arrangement, and like I said earlier, this will be quite easy. So what we need to do is, let's just take out this part, and in this case we'll be running the beams on these walls. Okay, so in this case we are running the beams on these walls and no longer on the ground floor walls. So remember that these walls and the walls on the first floor actually have the same position, so this makes everything a bit easier. So I will erase this, and I will run this beam from this point straight down to this point. Okay, so I will select this, and I will send this down. Okay, I don't think this is selected, so let me erase this and select this, extend from here to here. Okay, this becomes for my staircase area partition. Okay, and I need to run a beam. This one will act as a secondary beam on this primary beam, so I send this here and here, then I also send this here. Okay, and send this here. So this becomes one panel, this becomes another panel, this becomes another panel, this is another panel there, here and here. Okay, so we adopt the same thing for the mid parts. Please do not forget to share these videos with your colleagues, your course your friends. If you find them helpful at any point, it is just your little way of supporting us for the free videos that we upload on YouTube. Okay, so I will send this down to here, and I will send this down to this point. Then I will select this, and I'll extend this to, and I'll also extend this to. Okay, so I'll erase this. So with this, we are in less than no time we are done with our second floor structural arrangement, because this is quite similar to what we have on our first floor walls. Okay, so this is a slab panel, this is another panel, this is another panel, this as well, this is another panel, this is another panel. So this will most likely wrap up the general arrangement phase, and the next phase we'll be moving on to ProtaStructure to begin the modeling. After the modeling, we go to the pre-analysis, analysis, and the design phase. Okay, before we talk about designing our raft foundation. So if you found this video helpful at any point, do not forget to like it, subscribe, and turn on the notification bell so you get notified anytime we post new videos on our channel. All right, now we are done with our structural layout. So we have over here the ground floor structural layout, consisting of our proposed column positions that we are carefully positioned in between our walls. Okay, then we also have our first floor structural layout. So this is now the final proposed first floor structural layout, and we shall be using this layout in the modeling phase of ProtaStructure. So after this, we now have our second floor structural plan, which also consists of the columns on the second floor, starting off from this first floor. Okay, so the second floor layout can also be used for our roof column and beam layout. All right, so the next step after this will be going straight into modeling. So to take this to ProtaStructure, what we need to do is we'll copy the columns on the ground floor layout, because we'll be starting off with this column. Then we'll copy the proposed beam locations on the first floor. Okay, because we intend to model these proposed first floor beams on the ground floor structural layout, because the beams will be running on these ground floor columns. So why we are doing that is, on the first floor layout we already have some realignment. Okay, so what we'll do is we'll come to let's look at the layer of this. Let's come here. This layer is under a wall, so we'll come here and we'll use the quick select. We'll select everything here, come to quick select, we'll come to layer, we'll come to a wall. Okay, and we can select this. So let's select these grid lines as well, and we'll also select this. Okay, so we can create a copy of this selection. Let's just create a copy to this place, and we'll come back to the ground floor. We'll come here to quick select, we'll come to layer, and we'll select columns. Okay, let's select columns. All right, so we'll copy these columns, and let's copy from the intersection between grid line 1 and A. So let's select here, and let's also put this at the intersection between grid line 1 and A. Okay, so we'll select this part. Okay, so one more thing I'll be doing is to reduce the line width of this walls. So let me just select everything here, come back to quick select, let's come to quick select and come to layer. We are going back to a wall. Okay, a wall, we'll click OK, and let's take out the line width to about 5 mm. Okay, so this is just to differentiate it from the column positions, but clearly we can still see our proposed beam locations. So the next step will be saving this as a DXF file format so we can import it on ProtaStructure. And let's carefully observe the layers of these materials of this element. So if we select this, this is under a wall. Okay, if we select our column, this is under the column layer, and if we select our grid lines, this is under grid line indicated by a GL layer. Okay, so I will select all of this, and I will use W or the block command, and I will click on this three icon. Click on this three icon to select your preferred location. Okay, so we'll be calling this the name of the structure AK Chambers 2-story 2-story. Okay, and we'll save this. You can save at any of the year. Okay, you can save with any of the year, but I prefer going with 2018 DXF file format, and I will save this. Okay, so our project has been saved successfully, and let's head on to ProtaStructure. So if I minimize this and I come to ProtaStructure, and we'll be creating a new project. So I will click here, and the name of this project will be okay, we said this will be AK Chambers underscore, sorry, let's delete this. We'll come here, this is the project code. So AK underscore Chambers underscore 2-story, okay, underscore design. So ensure you use underscore. If you try to use your space bar, it will not function on ProtaStructure. All right, so we'll come here to our design code, and we'll be designing this with BS810, and we'll click OK. So just give it a few seconds to load the interface. Okay, so we have the interface open up, and the next step will be importing our just exported CAD file. Okay, so to do that, or to add that to this model, we can come to external reference drawing, and we'll click on this add icon. Okay, so this is the DXF file, and we'll click on open. So to import our members, our structural members, we'll click import, and let's turn off the wall layer because we did not intend to import any wall into this structure. We just need the lines to indicate the positions of our walls. Okay, so to import our columns, we'll come to column layer, and to import our grid line, we'll come here and we'll select this layer. We'll click OK, and we can now import these two features. So just give it a few seconds, and we can close this. Then we'll ensure our DXF file is active on the layout. Okay, so after this we can click OK. So as you can see, we have what the columns from the ground floor and our proposed beam locations. So if we come here to create a new view, okay, let's come here to views. We'll right click and we'll add a 3D physical view. So as you can see, these are the columns that has been exported. Okay, these are the columns that have been imported by our CAD file. So we'll come back to the plan and we can start modeling our first floor beams on these columns. Okay, so we'll come here to turn on these grid lines, and the first thing we can do, and we will do that quickly, is just to rename this grid to suit our architectural file, because in the course of this project we'll be making reference to the architectural file, and to be better we can relate the grid numbering to what we have on the general arrangement. Okay, so we'll quickly do that in a second, and to do that, just this is grid line A, so just click on this, come to properties, and so you just have to ensure that grid is not already existing. Let's see if we have grid line A on this model. Let's see, I don't think so. So we can just change this from A21 to just A, and let's update to see. So okay, this has been updated to grid line A. Okay, all right, so at this point we've been able to successfully rename our ProtaStructure grid lines to suit with what we have on the AutoCAD structural plan. Okay, so we'll start with drawing our beams, and we'll be doing our preliminary sizing. Okay, so for the first floor beams, we can start with a thickness of 500 millimeter, while for the second floor beams we can start with 450 millimeter, and for the roof beams we'll be adopting a thickness of 300 millimeters. Okay, so during the analysis and design, if we get to see that these beam sections are not sufficient, then we can in turn increase these beam sections. All right, so I will come here to model my beam. I will come to modeling and I will click on beam. So the width of my beam, I will use 230 millimeter, and this is the width while this is the thickness. So the thickness of my beam, I will leave this at 500 millimeter. Okay, so I will start in a very simple way. I will start with the perimeter beams, then I will come to the cantilevered beams. Okay, and after the cantilevered beams I can start inserting my slab at their respective positions. All right, so I will start from my perimeter beams, and I will draw from this point on this column to this, and straight down to this. Okay, so let's close this and let's see what we've done. If we click on the 3D, let's turn off the grid line. You can see this is the first floor beams that is coming on our ground floor columns. Okay, so we'll come back to plan view and let's turn on our grid lines. So we'll select this beam, right click, come to properties to take the properties of this existing beam, and we can draw from this column point to this for another perimeter beam. We'll also draw straight across to this point and straight across to this point. Okay, So let's quickly see this, and this is what we have. We'll come back to the plan. We'll turn on the grid lines. Okay, we'll select any of these. We'll take the properties as well. Then let's draw this beam here straight from this point to this point. Okay, and we can also draw this. This is straight from this point to this point. Okay, so this is the advantage that comes with making your general arrangement on the AutoCAD. You can just import to ProtaStructure and you can trace these lines in order to achieve what you intend to model on your structure. Okay, so it makes everything easier. So this is the next line of beam, and we'll draw from this point. Okay, or let's start with this. We'll draw from this point because this will be a primary beam, while this will rest on this as a secondary beam. So we'll draw this primary beam from here to here. We'll draw this to this point. We also draw it here to this column point to this, and it will rest on this as a secondary beam. Okay, we can in turn extend this because this shows we made provision for extension here. So we can in turn extend this to this point, and this little arrow here indicates that this is a cantilevered portion. Okay, so we can also cantilever from the left down to this part, and the next will be this grid line. We'll draw from here to this point to this as well. We'll take it down to this. We'll take to this. We'll take to this point, and we'll have this resting as a secondary beam on this primary beam, and it cantilevers outward. Okay, let's close this. Okay, and this is what we've done with our respective cantilevers. So we'll keep moving forward here, and we'll come to properties. Then we'll start off with this beam here. So we can draw this cantilevered portion here. Then we'll start from here, and this rests on this as a secondary beam, also rest on this as a secondary beam, and it cantilevers outward to this point. Okay, this also cantilevers outward to this point. Okay, and let's finish these vertical beams. So from here we should have a cantilever going outward, and from this point on this beam line we have this resting here, we have this resting here, and we have this as a cantilever. Okay, so same as this cantilevers to this point, and this comes to this point. Okay, from this point a secondary beam up to this, and this cantilevers outward as well. Okay, so we are almost done with our beam arrangement, and let's add these cantilevers. This goes from here to here, and this goes from here to here. This also goes from here to this point, while this also goes from here to this point. Okay, so this goes from here to here, and this goes from here to here. So we also have this coming here, we have this from this position coming here, we'll have this going up only. Okay, and let's see, we have this coming here, this point. We also have this coming here to this point. Okay, this comes from this beam to here, this also comes from here to this point, and this comes to here. We also said we can design this as what, as can design this part as a cantilever slab. Okay, so let's see, this is what we've done so far, and let's add these extra beams at the edges. Okay, so we'll turn back on our grid line, we'll select any of this, come to properties, draw from here to this cantilever, from here to this. Okay, and we'll cantilever this short length. We'll send this here, and we'll cover this up with this part. Okay, so we'll also add this here. This comes here, this comes to this edge, this comes to this edge, this comes here and here, and close up with this. We can have this with this, and this with this. Okay, so we'll also go from here to this point, and this goes from here, and this goes from here. So while you are making your cantilever section, you should be sure that the beam that has this arrow is the shorter beam. Okay, so between this and this is the shorter beam. So ensure you cantilever this shorter length, while this longer length can rest on the beams. The ones at these edges should not be the beams that has this uh, triangular indication. Okay, so this closes up with this, and this closes up with this, and I believe we must have completed what we proposed on the first floor beams. Okay, and we can start inserting our slabs. Okay, so if you find this video helpful at any point, do not forget to like it, share this video to your colleagues. If you find it useful, share it to your friends, share it to your group chat, and in case you want to practice with us, do not forget to get our card file from our online store. Okay, you can get the AutoCAD file from the online store. You can also get it with the architectural file if you wish to. So the advantage of getting this with the architectural file is because it does not only give you the architectural file for this design, it provides you with additional architectural file, because on the architectural file we have two different structures on that very model. So you can use that other card file to do something different. Okay, so to insert our slab on these respective beams, we'll come to slab. So we can start with our preliminary sizing as well, and we'll be adopting a slab thickness of 150 millimeter, and our concrete cover will be taking a concrete cover of 25 millimeter. Okay, so we'll come here to load our slabs, and our self weight of the slab has already been calculated by multiplying the characteristic strength of our concrete by the thickness. Okay, so for this dead load, we shall consider partition and finishes, because we will be having walls constructed on our slab, right, which does not run directly on these beam lines. So we can consider partition and finishes, but to make everything easier, I will just come here to select a predetermined load here for our room. Okay, so this will take dead load as 2.375. Then the imposed load is for a general domestic use. So I will right click and I will take this 1.5 kilonewton per meter square for a general domestic use. All right, so no roof load, no snow, and no rain load. So I can place my slab at any point between these beams. So we'll close this, and let's come to the 3D. Okay, so we'll come to the 3D. You can see this is the slab that has been placed on our beams. So we'll select this, we'll right click, take the predetermined properties, and we'll put this here. We'll also put this here. Okay, this is our stair area, so we'll put this here. We'll put this here as well. This comes here, slab here, this. Okay, this slab comes here. We can have this panel, this slab panel, this, and this. Okay, so the next comes at this point and at this point. Okay, This also goes there at this point and also at this point. Okay, so the next is this and this. Okay, and I believe we should be done. Okay, we have one more by the left here, this and this point. We can put this and this. I believe we should be done, and the next step will be inserting our cantilever slab. So our cantilever slab is at this point and here, and we also have it at these other edges. Okay, so let's come to the AutoCAD file. Let's come to the AutoCAD file, and if we dimension these parts from here to the edge of our slab, we have what, 300 millimeter. Okay, and also from this point to the end of our cantilever slab, we have 600 millimeter. So I will come back to Prota. So I'll come back to Prota and I'll select this or select any of this slab, come to properties here, and I will come to this type to change to a cantilever slab. I will come here and I will select type 12. As you can see, we have it fixed as one end and the other end are free. Okay, so this is the indication of a cantilever. So we'll select this, and as you can see, a new tab has been created. So we'll come to this new tab and we'll keep all the loading as what we have on this previous slab. Then we'll come to this new cantilevered part and we'll edit this L count. So for this part over here, our L count will be 300 to indicate 300 millimeters. Okay, then we'll come from this point to, okay, let's turn on our grid lines. Let's make our grid lines. So we'll click from this point up to this point and we can take it towards this direction. Okay, so now we have what, this cantilevered part of the slab. We can also draw from here to here and we have this cantilevered part. So if we close this and let's get to see. So this is what we have so far. Okay, the 300 millimeter cantilever slab. Okay, so we select this, come here to properties, and it will take all the properties of this other slab. So we'll select from this point to this point. Okay, we'll also select from this point to this point and we'll take it upward. We'll select from here to here, also select from here to this point. Okay, and the last should be from this point to this point and we'll go towards this direction. Okay, so the next cantilever slab will be around here. So we'll come back to cantilever and we'll change this to 600 millimeters, and we can draw from this point to this point and this here. And we can also draw from this point to drop this at this location. Okay, so if we close this, come to 3D, we'll turn off this grid line, and this is our first floor slab. Okay, which aligns with what we made on the general arrangement earlier. Okay, so what we've done so far is to model our ground floor columns with the respective first floor beams. Okay, so some of these ground floor columns are continuous on the first floor structural layout, but we also have some columns that are starting on the first floor. All right, so we need to make these modifications in order to bring out these columns. So let's come back to our model. and we'll create other stories on this very model. Okay, so to do that, we'll come to building setout, and we'll come to story operations. We'll come to insert stories, and this series is a ground plus two suspended floors. So the ground is one, the other two floors are two, so that gives us a total number of three. So here becomes three, and we'll click OK. All right, so we'll just give it a few seconds to load, and I will turn on our grid lines. Okay, so if we come back to story one, okay, we can push the columns that are on the ground floor to the first floor, and from there we can start making modifications as regards to what we have on our proposed first floor general arrangement. Okay, so to do that, we'll come to story operations as well. I will come to generate story. Okay, so we're generating from story 1 to story 2, and we'll be taking out all our slabs. We'll also take out braces, beams, shear walls. We are only transporting the columns from our story 1 up to our story 2, so we can make those modifications we did earlier. Okay, so I will click OK, and my columns has been transferred to this story. Okay, so let's come here to 3D, and this is what we've done so far. All right, if I turn this off, this is what we're able to do. Okay, so to make this easier and better understood, I will have to put this side by side with the AutoCAD file. So let me put the AutoCAD file here. Okay, and let me drag this down to the left. Let me increase this a bit. This should be okay. Let me still drag this down. Okay, all right, so this should be okay. Okay, so we'll start off with this part, and we said on this story here, we said this column will be discontinuous, so we have this in red, right? So the columns on grid line 5, which is this, will be discontinuous, and it will be transferred to grid line A asterisk, which is this grid line A asterisk. Okay, so it's moving from grid line A to A asterisk, both here and here. So I'll come to the properties, and I'll take the properties of this column, and I'll transfer it downward here. Okay, and I'll also transfer it down to this place. Then I can erase this as my discontinuous layer. Okay, so I'll do the same for this. This moves from this grid line to grid line 3 asterisk on the same line. Okay, so I'll come here, come to properties, move it from grid line 3 to 3 asterisk, and I can delete this. Okay, so we'll move up to the next column. Okay, so we have this continuous on 3 asterisk, and we have this on 2 asterisk. Okay, the same line, so we have this here, and this moves from this position to this 2. Okay, so we can come here to, and we'll select here, come to properties. We are transporting this from here to this point and this point. Click, and we'll click here. Okay, so we can go ahead to delete this column. All right, so this is the good thing about creating your general arrangement. You already have a full idea of what you intend to model when ProtaStructure or any of the software you are designing with. You have a full idea of what you intend to model, and it makes everything easier. So this is continuous, this is continuous. Okay, and on grid line 3 over here, on grid line 3, we have this moving from this position to B asterisk. Okay, so we have this on grid line 3. This moves from here, come to properties, and it moves here on B asterisk and intersection of grid line 3. So we can escape and delete this. Okay, so we had this column moving from this point as well. I guess we which is this column on grid line 5. Okay, so let's see the column on grid line 5. Yeah, so we had a column here. I guess that was missed out, so let's copy it from this place to this place. So we had this moving from this grid line to this point as well. So we'll select this, come to properties, and we can drop this here, and we have a column just below this point. Okay, so we can escape this, and let's see what we've been able to do so far. So if we come to our 3D, so as you can see over here, we have this column continuous. Let's turn off this. We have this column, okay, on the ground floor, which is this, and is this beam is running on this column from this point to this point, which is from this point to this point, and it cantilevers outward. It cantilevers outward to this part over here to receive this other column. Okay, while this is running on this direction, this, which is this as well, and it cantilevers outward to receive this column on the next floor. Okay, so this is just what we've been doing, and we'll try our possible best to be a little faster. Okay, so we'll come back to the plan view, we'll turn back on our grid lines, and we'll move to the next section. Okay, so at this very point in time, we've been able to complete our column modeling, and this is what we have. So if we turn off this grid lines, so we have this. Okay, so we have this as the new columns that are starting off at this very level. Okay, so the next thing we need to do is to model our beams. Okay, so to model our beams, we'll come here, and we'll select this. Let's maximize this, come to modeling, let's come to beam, or we can still put this side by side. Let's put this side by side. Okay, let's come to beam, and for the preliminary sizing of the second floor, okay, the beams, the second floor beams, we shall be using a thickness of, we shall be using a width of 230 millimeter and a thickness of 450 millimeter against 500 millimeter. Okay, so this beam over here, let's start with this beam here. So we start with the beam on grid line B as there is, so it runs straight down from this point up to grid line 5 as there is, which is this. Okay, so we'll have this straight beam here, and the next is this as well. So we'll have this straight from this point up to this point, and we'll move on to grid line E as there is. We have it straight down to this point. We have it straight from this point to this point. Okay, and from grid line I as there is, we have it straight from this point up until this point. Okay, so we have these 4 straight beams, and we come back to the perimeter beams. Let's come to the perimeter beams. Okay, so we have it from, let's draw this cantilever first, because the longer one has to rest on this shorter one. So we'll draw from here to this point. Okay, and we can take directly from this point to this end. All right, so we'll take directly from this point, and it cuts across all these other columns, cuts across all these parts up to here and up to this point. Okay, and it cantilevers to the right. Okay, it's the shorter beam here, so we'll put this at this position. Okay, so we'll come back to the next grid line, or we'll take this from this point to grid line 2. So we'll take it to grid line 2. Okay, we'll also take this from this point to here, and we'll join it with this. We can join this and this together, just like we have over here, and the shorter one cantilevers to this point, okay, while the longer one cantilevers to this column. The shorter one cantilevers to this, it cantilevers to this column, okay. So when we have our general arrangement, you can see it makes things a lot easier. So from here we can join this to this part, and we can also join this to this part, okay. So we'll join this to here, we'll also join this to this part, and we can join this part to, okay. So let's close this and let's see what we've done so far. We'll come to the 3D view, okay. So these are the columns starting off, and these are the beams to receive the next floor. All right. To understand how we came about this, I will advise, if you didn't follow up from the general arrangement phase, you go back to that phase and you fully grasp the procedures, okay. So let's come back to our plan view, and we'll turn back on our grid lines, and we'll do this a little faster, just in order to save time. So at this very point in time, we've been able to complete the modeling of these floor beams, and the next part will be inserting our slabs, okay. So this is as we have on this very model over here, okay. So we'll maximize this, and we'll come to modeling, we'll click slab, and we'll still use a slab thickness of 150 millimeters, okay. We'll come to this loading, we'll still pick our room dead load, and imposed load will still be a general domestic use, and we can insert our slabs at these respective positions, okay. And let's turn on our grid lines. So we insert our slab here, okay. We insert here as well, drop this here, here and here. We drop this at this point here, this part, okay. Can put this here, here, then this part we have here, okay. We have this part of the slab, this finally there. So this is our stair hall, so it doesn't need slabs, okay. So let's come to the 3D, and this is what we've been able to achieve so far, okay. This is what we've been able to achieve so far. So the next point will be exporting the columns and our beams to this level, so we can have our roof beams, okay. We can have our columns that start on the second floor and have our roof beams, okay. So to do that, we'll quickly come to plan view on this story, and we'll come to building setout, we'll come to story settings, we'll generate stories. In this case, we are generating columns and beams, so we'll take this out, we'll take everything related to slab out, and we are generating from story 2 up to the story 3, okay. So click OK, continue, and the process has been completed. All right. So let's come to our 3D view, and with this, we will be able to complete the modeling of this structure, because the structural arrangement we have on the second floor is the same thing as what we have for the roof beams. All right. So the next step will be, we've loaded our slabs, we've applied the load on our slab. The next step will be loading our beams, right? Because we'll be having beams, we'll be having walls running on these beams. And I think there's a part of the cantilever here that we have, that we need to add to the story 2. So let's come back to plan view, and let's head on to story 2. So there should be a cantilever slab of 600 millimeter here, just like we have on the card file, okay. There should be a cantilever here which is about 600 millimeter here, okay. So we'll come back to the Prota file, and we'll select any of this. We'll come to properties, we'll turn on these grid lines, and we'll come to selection type, and we'll change this to type 12, which denotes our cantilever. Okay, automatically the cantilever tab comes out, so our L count turns to 600 millimeter, and we can draw from this grid line to this grid line, and we'll bring this down here. Then we'll draw from this grid line to this grid line, then we can bring this here. Okay, so let's close this, come to 3D, and we'll turn off. So yes, here we have what the cantilevered part of our structure. Okay, so if you found this video helpful at any point, do not forget to like it, subscribe, turn on the notification bell. Do not forget to share this to your colleagues, your uh do not forget to share this to your colleagues, your engineering group chats, and your course mates if you are still a student. Okay, this is just a way to help us out with the free tutorials we create on YouTube. All right, so we'll come back to the plan view and we'll start to load our beams. So it takes account of the walls that will be constructed on these beams. So we'll start this off from the, let's start from this story 2, because we'll be having walls running on this story 2. So we'll just select one beam. Okay, then we right click and we'll come to edit wall load. All right, so editing our wall load, we'll be adding the unit weight of a 9 inches block, or we can say we'll be adding the unit weight of a 225 millimeter block. All right, so I'll be making reference to a specific material which I always do. It's called the Fundamentals of Reinforced Concrete Design by engineer Dr. Victor Oyenuga. Okay, a very renowned structural engineer in my country and all over the world. Okay, so I will bring up this material, and if we head on, you can get this material online. Just search it, you'll be able to see it online. So if I come down to page 3, so as you can see over here, we have what the basic unit weight for our block walls. For 225 millimeter, this is 2.87, and for 150 millimeter hollow block, we have 2.15. Okay, so I will come to this story, and the wall unit weight, I will change this to 2.87. Okay, and our wall height is 3 meters, of course. Then our wall thickness is 0.225, is 225 millimeters converted to meter. Okay, so the dead load on the wall, on the beam, will be calculated. That's the dead load on the wall being transferred to the beams will be automatically calculated here. So I can click OK. So if we come to 3D view, you can see over here we have this wall load. We have this wall load applied on that very beam. Okay, so I will come back to the plan view and I will right click. I will select this beam, right click, and I'll come to copy wall load. Okay, so I will copy this and I'll put it on all the existing beam on this very level. Okay, so I will select the first beam, then navigate downward, hold my shift button, select the last beam, so all the beams are highlighted. Then I will right click, then I will come to paste copied beam loads. Okay, so I will click here and I will click OK. All right, so let's come to the 3D view. We'll come here, and as you can see, our respective walls has been added to our respective wall load has been added on our beams. Okay, so I will use the same approach and I will apply the same wall loads on our story 1 beams. I'll come here, I will select, I'll come to beams, select the first one, navigate to the last one, hold shift, select this, right click, and I will paste copied beam wall loads. Okay, then OK, and the operation has been completed, I will deselect, come to the 3D view, okay, and we have our wall loads applied on this very model. So if we come to the AutoCAD file, you will observe that we have, okay, you will observe that we have some walls on this roof. Okay, on the roof beams we should have some walls, because these walls will cover the roofing sheet. Okay, we cover this sloped roofing sheet over here, so we have some walls constructed here. So this will cover this sloped roofing sheet, so this looks more like a flat roof. Okay, so when you are looking at it from the outside, you can only see, if you look at it from this elevation, you can only see these walls, and these walls will be constructed with a 150 millimeter block wall. Okay, so if we come back to the material and our 150 millimeter hollow block, the unit weight is 2.15. Okay, and if you come here to dimension the length of our wall, dimension from this point, let's take from here to this point, we have about 1.6 meters. Okay, so we'll come back here and we'll come to the ProtaStructure, then we'll come back to, and on the plan view we'll to story 3, then we'll select one of these beams, we'll come to properties, and we'll come to edit wall load. Okay, in this case our unit weight is 2.15, our wall height is 1.55, our wall thickness is 0.15, which is 150 millimeter. Okay, so we can apply this magnitude of wall load to the roof beams. Okay, we'll come here, we'll copy wall load, and we'll come here, we'll select the first beam, we'll select the last beam, we right click, and we paste copied beam load, then this should be okay. All right, so the next is we have to reduce these roof beams. Okay, because this was automatically transported from our story 2, so we have to reduce these roof beams to 300 millimeter. Okay, so let's come here. So these are the walls that has been added to the roof level. Okay, so let's come here to story 3, we'll click on beam, we'll right click, come to beam table, and as you can see, the depth or the thickness of our beam is 450 millimeter, the width is 230 millimeters. Okay, so we'll click here, we'll click on this column wise edit, and we can change this to 300 millimeter. We'll click OK. Everything has been modified to 300 millimeter. So we can close this, and we'll go ahead to save this model. Okay, so we can save this. So the next point, we'll be moving from the modeling phase to the pre-analysis phase. Okay, so this is where we get to define some project parameters that will help us to analyze this structure. Okay, so the first pre-analysis option we'll be going to is we'll be looking at our load and load cases. Okay, we also look at some important project parameters, and finally we can get to select the grade of the reinforcement, the concrete, the diameters that will be used in the design of this structure. So we'll start with the first, which is, if we come to loading, we can look at the load and load cases. Okay, so currently we do not have any predefined load and load cases on this structure. Load cases and combinations. Okay, so to do this, we can use the automatic load generator that comes with ProtaStructure, and we'll just come down to load generator. Okay, so we have our defined dead load, our 1.4 GK and our 1.6 QK, just like our manual calculations. Okay, so we can also create an unfactored load combination so that we can have our 1.0 GK and our 1.0 QK. Okay, so this is for the vertical loads, and we'll come over here to the horizontal loads. So we ensure our notional horizontal load is ticked because the BS code specify we apply the notional horizontal load to all structures irrespective of the height. Okay, and this is about 1.5% of your total dead load. So we'll ensure this is ticked, and our BS 6399 part 2 specifies we apply wind load to structures that are 10 meters and above on a flat terrain. Okay, so this is a 2 G+2, so we are limited to about 9 meters thereabout. If this was a G+3, then we can apply this wind load. Okay, but for our horizontal load, the notional horizontal load should be able to cater for those horizontal forces. So we'll leave this as vertical, and we can also define uh, another pattern loading. All right, so you can go through our video on flat slab where we'll systematically explain what this pattern loading does. All right, the truth is we've made different videos on each and every of these topics. So in case you need clarity, in case you need further understanding, you can always make reference to them, and I will try my possible best to ensure that I leave the link in the description so you can also look at them at your free time. Okay, so I will click OK, and the load cases and load combinations has been automatically included. So I will click OK to save this, and the next point will be inserting some important project parameters. So I will come to the analysis tab, and I will click on building analysis. Okay, so I will come back here to project parameters, and I will do my checks. I have BS 8110 for the code of use, BS 5950 for steel. This is my loading code, BS 6399, which I just made reference to. Okay, so for the foundation, the soil bearing capacity of this site, well, we can edit this when we get to the foundation design stage. So I will definitely leave this at 200. I'll leave this for now at 200 kilonewton per meter square. Then the lateral loading, we've been able to tick our notional horizontal load earlier, which is about 1.5% of our total dead load. So this is okay. Our lateral drift braced and braced on both direction 1 and direction 2. Then we can insert the title of this design course. So let's call this complete raft design G+2. Okay, so this is made by us and is checked by myself. So project number, we can leave this, and we can also leave this, but you can choose to insert your own specific project numbers, and if you wish you can insert your date as well. So I will click OK. All right, so the next is setting the grade of steel and grade of reinforcement that will be used in the design of this structure. So to set that, we have to click on edit materials, and under default materials we'll be looking at our concrete columns. So to select our FCU, which is our grade of concrete, you click here, and you can see the different grade of concrete available for you to design with. So for the purpose of this lecture, we'll be designing with grade 25/30, and not just for the concrete columns. I would like to apply this to every structural members on this very model, both my beams, my slab, and any other structural members if there was any. So to do that, I will click on apply to all members of this material class in this story. Okay, so this is okay. then everything here, both the concrete columns, concrete wall, the slab has been changed to 25/30. So for grade of steel, I will leave this at grade 410. Okay, and for the rebar diameter, for my concrete columns, I will click here. Okay, then I will unselect everything, and for the columns, I will start with a minimum section of Y16. I'll also consider Y20 for my columns, and worst cases I should have Y25. Okay, so these three columns, these three steel diameters are okay. And for concrete walls, we do not have concrete walls on this structure. For my concrete beams, I will select the same three diameters: 16, 20, and 25. Then I will look at my slabs. For my slabs, right, I should be designing with just Y12. And the next material will be rib. We do not have rib slab here. Is our links. Okay, our links, we can alternate between Y8 and Y10. Okay, so either of this is okay. So I'll select these two options, and I'll click OK, and I'll close this. All right, so now we've been able to complete our pre-analysis phase, and let's move on to the analysis phase. Okay, so the analysis takes just few seconds, and to run our analysis, we'll come back to building analysis. Please, if you found this video helpful at any point, do not forget to like it, do not forget to share it to your friends, do not forget to subscribe to our channel, and just share it to your friends, share it to your colleagues. This is just a way of helping us out for the free tutorial we do on YouTube. Okay, and do not forget to get the card file in case you want to practice. And like I said earlier, the importance or the advantage of getting the AutoCAD file coupled with the Revit architectural file is that there is another set of architectural file in the Revit, okay, that you can also practice with aside with this very structure which you have over here. So there is an extra card file to practice with. Okay, so we'll come to the analysis, and the first thing is we'll run a building model check. So this is to enable us see if we have any pending issues on this very project. So we'll click on building model check, and we'll start this. All right, so we'll look out for the errors, and the building model check, the numbers of errors we have is 1. So let's go up to see this error, and if we come here, you will see story 1 IS37 has a very small area. Okay, so if we close this and we'll close this, and we'll come to story 1. Let's come to story 1, and let's click on our slab. So it says I1S37. Okay, the 1S37. All right, so it's speaking about this part. It said this part has a very small slab area. So this is a negligible error. Okay, this is a negligible error. So we can do away with that error message, and let's head on back to the analysis, building analysis. So aside from that, we do not have any other error on this very model. We do not have unsupported columns or any other errors. So we'll now have to perform our analysis, and to do that, we'll click on building analysis. Then we'll be just running, we'll just get to run analysis. Then after analysis, we'll go into design proper. So because of that, I will not click any of these design options. So I'll just click on building analysis. So you give a few seconds to load, and this depends on the capacity of your laptop. Okay, so in about 23 seconds, our analysis has been completed, and our relative story drift satisfied the limits both on the direction 1 and the direction 2. Okay, so to delve more into this relative story drift, there will be a different course to handle this very section, so it fully understands what we are talking about. But for now, it satisfies both on the direction 1 and satisfies both on the direction 2. So we'll close this, okay, and we'll go into the post analysis phase. So we can also close this and we'll close this, okay. So this is our line model of all the structural, this is our line model of all the connected members on this model, okay. So if we want to see our displacement or how our structures will deflect under each of these loading combinations or load cases, we can just click here on displacement, okay. So under our dead load, which is the currently selected load case, this is how our structure will behave. Then under our pattern dead load, this is how our structures will behave. So we'll check with our load and load cases, we'll check with our load combinations rather. So your BS 8110 part 2, which is the 1985 of the BS code, it specifies that we'll check our deflection with the serviceability limit state, okay. So let's come to the serviceability limit state where we have 1.0 GK and 1.0 QK. So we'll click on this, okay, and we can see the maximum deflection here. This is about 0.00723 meters. This value is in meter, while the minimum deflection is about 0.0028 meters. So if we click on this max, it will show us the point where we have the maximum deflection. So we can calculate this maximum deflection, and let's see what is the maximum deflection we have on this model. So we have what, 0.007. So if we take 0.007230 and we'll multiply this by 1000 to convert to millimeter, then we should have in our maximum deflection as 0.23, okay. So to confirm this is okay, you have to get the length of this current section and divide it by what the code specifies. You have to get the length of this section and divide it by 250, so that should be your allowable. Then compare it to the result which you have over here, okay. Our cantilevers should be 180, okay. So we are done with the post analysis phase, or let's just check other load and load combinations. If we check the notional horizontal load, which is hitting these structures from the side, you can see the deflection. And let's see this in animations, okay. So this is the notional horizontal load, which is hitting these structures from the side, okay. So this is how our structures behave under this load case, okay. So this is how it behaves from the coming from the notional horizontal load coming from the y-axis, okay. So we can also check our deflection under the the serviceability limit state. We can also check under the ultimate limit state, okay. So these are other pattern loading which we defined earlier. So I will stop this, okay, and the next is I will close this analytical model. And since our deflection satisfied, we can start with our design proper, okay. So to head on to our design proper, we'll start with designing the slabs and we move over to the beams, and after that we can move over to the columns, and finally we can start the analysis and design of our raft foundation, okay. So to design our slabs, we'll get to use what we know as our slab strips, and you can find that under the modeling tab, okay. So our analysis has already been done. We have what our result. So the next phase will be what, designing the slabs. So we'll click on slab strip, and to design a simple solid slab like this, you have to make use of what we know as the analytical strip, okay. So we'll start off from the X direction, which is this direction here, and we'll set the boundary conditions of our slab strip. Okay, so from this X direction, the first slab we have over here, the boundary condition here, we have a beam. Okay, and also at this end we have what, a beam over here. Okay, so we'll select the start should be a beam and the end should also be a beam. Okay, so we'll just click here, hold our control button to create a straight slab strip, and we'll click here. Okay, so as you can see, the reinforcement that will be used in constructing this slab section has been provided. Okay, both the bottom and the top reinforcement. So that's for this section. Then for this part here, we also have a beam here, and we have uh, a beam at this end. Okay, so we can't draw from this place up to this place because we have this part that doesn't have any slab. So we'll draw from here to here, and we also draw from this point to this point. So what I will advise you can do is, after this lecture, you go back and look for our specific videos on slab analysis and design. I believe we should have about 2 videos at this point that specifically details slab analysis and design. Okay, because if we have to go through the whole processes of slab analysis and design, then we'll be spending just about another hour thereabout on slab analysis, but we'll be touching the key and the most important points in your design phase. Okay, so let's also run this here, and due to time I will not run my strip on all of the slabs. So let's run this last slab strip on this direction, and we'll come to the Y direction. Okay, so we'll come to the Y direction, and our boundary condition here, we have what, a slab starting here, and at this end we have what, a beam. So we'll come here to a cantilever slab. This is a cantilever slab, so we'll click start cantilever slab, then the end will still leave this as a beam. So we'll click from here. Okay, and we'll drag this down to this point. Okay, then at this other part as well, we'll click from here and we'll drag this down to this point. While on this part, we'll start from this down part because we have the cantilever at this down part. So we'll draw from here up to this point. Okay, and let's get to investigate this few slab that we've done at this very moment. So if we close this and we'll tend to look at this section, you can see we have what, our top bar, which returns from our cantilever slab right into this part of our supporting slab. Okay, so this is the top reinforcement that returns from this cantilever into this part, and by our code of practice, this should return at least 25% of this span beyond the position of this beam. Okay, so we have this as our top bar returning, and this is our bottom bar. This is our bottom bar, is our B1 because it's running on the shorter axis of this point. Okay, then this is our second bottom reinforcement, and it is our B2 because it is running on the longer axis between this direction and this direction. Okay, on this very specific slab. So this is our top bar that goes into the slab on the right hand side and goes into the slab on the left hand side, which is about 25% of the right hand span, and this part also goes into this to at least 25 to 30% of the left hand side. Okay, so to understand this better, go to our video on slab detailing, and you'll be able to get a detailed analysis of how our slab reinforcements are placed. Okay, so at this point in time we are done with our slab strip for this very level. Okay, so let's also come to the level 2, and let's quickly run the slab strip on very few of these slabs. So this boundary condition is beam to beam, and we'll start on the X direction. So we can draw for this. Okay, and let's also draw across this point. We can also draw across this, and let's also add this part over here. Okay, so the next, we'll just come to the y direction. We also have this beam to beam, so we'll select from this point, hold our control, and we'll drop this here, and we can drop this from this point to this point, and we can drop this case. We are starting from a beam and we are ending at a cantilever. Okay, so we'll draw from here and we'll drop this here. So we'll also get to observe the reinforcement. So this is our returning top reinforcement. You can see this is not as lengthy as we had on the story one. So on the story one, we had this returning deep into the other section because we had a cantilever at this end. Okay, so this is our bottom reinforcement, B2 running on the longer axis and the B1 running on the shorter axis. So the next step, we'll be making checks on our slabs to ensure that our slabs are satisfactory. And to do that, we'll come to the design phase and we'll click on slab analysis and design. Okay, so we'll tick all stories and we'll not modify our steel. We'll not modify the steel that has already been provided at this point, or we can just delete and let's reselect everything. Let's delete and reselect all the reinforcements. So we'll click this and let's save this report. This is how you can save your calculation sheet. So this is a calculation sheet for our reports. Okay, this is the calculation sheet for our slab analysis and design. So we can save this as slab design AK chambers G+2. Okay, and we can click save. So let's go ahead to investigate the results. And as you can see, for the first slab section, okay, which is IS27, this is our deflection check. 5.04 is less than 52, so our slab depth is what sufficient. Okay, this is for I1 slab 1. We can also check for our deflection. So the reinforcement provided at this section, we have what Y12 at 250 for both the top reinforcement. We have what Y12 provided at 250 for the bottom reinforcement. Okay, so you ensure you check the deflection for each of these slab. This is 17.02 is less than 52. Okay, this is sufficient. Another deflection check, we have 17.02 less than 52. Okay, so you check for this section as well. For the story one, we have at this point 5.04 less than 52, 31.43 less than 52. Okay, so we can come here to search if we have any insufficient section, and if we had any insufficient section, we should be able to have this highlighted in yellow. So let's check, let's confirm if we have any sufficient. So as you can see, just by typing this, we have sufficient. But if we go back to type insufficient, we do not have any of these slabs as insufficient section. So with this, we can pass our slab design. And like I said earlier, to get a detailed analysis of what you should do during your slab analysis and design phase, just go to our specific video made for slab analysis and design. Okay, so we'll close this and we'll close this up. Okay, and we can say we are done with what our slab analysis and design. So the next phase, we'll be moving on to our beam designs. Okay, and to design our beams, on this design tab, we'll come to our story beams. So as you can see over here, the design of our story beams are marked X because we've not done any previous design on this very structure. So to perform our beam design, what we need to do is click on beam design batch mode. Okay, so we'll click here and we'll come here to ensure this is selected to all stories unless except you want to design for a specific story. And we'll click here to reselect all reinforcements and we'll click calculate. Okay, so to further understand the beam analysis and design, we've also made a different video on beam analysis and design. Okay, so you can understand this in depth. So you just give it a few seconds to calculate. And at this point in time, our beam design has been completed. So our beam analysis and design has been completed on this structure. Okay, so let's go over here to investigate some of the reinforcements that has been provided for our beam sections, and these are the utilization ratio. Okay, so the utilization ratio is actually the ratio of performance of your both the concrete section and the steel section as compared to the load that is being applied on it. So like I said earlier, to get an in-depth knowledge on these courses, I'll prefer you always go to our specific videos on the different topics. So head on to our video on beam analysis and design. It is about an hour video, so we can't combine that 1 hour lecture to this very lecture. Okay, so we'll only give you the basics in this very case. So we'll come here and let's investigate this beam to see the section that has been provided. Okay, so this is our top bar, and on our top bar we have 2y16. On the bottom we have 2y16 as well. Okay, the top all over here is 2y16, the bottom is 2y16. So we can click OK, and let's also check some of these other sections. So we also have 2y16 and 2y16 both top and bottom reinforcement. So let's close this, and what I would like to investigate are some specific beams. So I'll come to story 1. Okay, let me come to story 1, and I would like to investigate this beam that spans all the way from this point, okay, and cantilevers to receive this slab and carries the 2 stories that comes on it. It spans from this place to here to here, and another cantilever at this edge. Okay, so this is the first cantilever, which is 1B44. So if we select this beam and we'll go back to the section design, so you can see this part of 1B44 is where we have what 3Y25. Okay, the top reinforcement for that part is 3Y25, and this is expected because this carries the other two the columns that are suspended on it on the other 2 floors. Okay, so we can choose to take this to against 3y25. Let's see if we can use 4y20. So as you can see, 4y20 is still sufficient on this very section. Okay, so this other top section next to it requires 2y20. We can change this to 3y16, and like I always say, when you are trying to change the reinforcement, always ensure you look at your extra area of steel provided, which is over here. So this is less than 70, is less than 100 as well. So we'll increase this to 4y16 so we can have a better value over here. To better understand all this value, please just head on to our beam analysis and design course. Okay, so we also go to this other part. So this small part here, it requires what just 2y16 for this other cantilevered section. Okay, so I am satisfied with this beam and I can click what OK. So this point in time, we can say we've completed what our beam analysis and design on this very structure. So we can go ahead to investigate every other beam. One thing you shouldn't forget is, so if you open any beam, let's select this and we'll come to section design. Okay, so ensure you always check for the deflection over here. Ensure you check for the deflections. Okay, so ensure you check this to make sure it's what satisfactory. So we can close this and we'll head on to our column design. So to perform our column design, we'll still go back to the design tab and we'll click on our columns. Okay, so because we've not performed any previous design, this part is also expected to be ticked X. So to perform our column design, we just have to click on column design batch mode. We also ensure all stories are selected unless except you want to design for a specific story, and we'll tell it to what reselect all reinforcements. Okay, so we'll click calculate and you give a few seconds to load. And our design has been completed, so let's close this. Okay, so as you can see, our design status has changed to has been marked green. Okay, so we'll click on any of this section to see the reinforcement provided. So as you can see right here, these are the reinforcement that has been provided. Okay, so if you come to this part, you will see we have what 4y16 for this very section. For this section as well, we also have what 4y16, and we have our links as y8 provided at 175mm center to center spacing. Okay, so all our columns are okay, and let's also check this. So these are the positioning of our reinforcement. Okay, our 4y16. All right, so I will click OK, and this is it for the column analysis and design. If you need a specific video, of course you should know what to do. So we'll close this. So at this point in time, we'll be able to complete the slab design, the beam design, and the column design. So the next phase will be heading on to the foundation design, because all the superstructures has been was completely designed. And to confirm this, let's come to the 3D and we'll come to review over here. Then we'll click on visual interrogation. Okay, so we'll click here to see our design status, and as you can see, we have everything marked green on this very model. Okay, if we have any filling section, we'll see this in red. Okay, so this is the model. So let's head on back to visual interrogation, and let's take this to none. So we can close this and go back to the plan view. All right, so to begin our so when you want to perform your foundation design, you head on to story 0. Okay, and let's turn on our grid lines. So as you can see, we have what our columns that start from the ground floor transfer to the foundation level. Okay, so what we can do is we'll come to the building setups and let's import the CAD file we used in the modeling of our first floor. So we'll just come to external reference drawing, and over here we'll change this from story 1 and let's bring it to story 0. Okay, so we can still see the proposed location of our beams. So we'll be designing this with a beam and slab raft foundation. So it means we'll be having our beam and we'll be having our suspended slab resting on our beams. So we'll start with modeling our beams, and to model our beams on this very level, we'll still come to this modeling. Okay, and we'll click on beam, and we'll set our beam width to be 230mm, or we can as well design this with a 250mm section, since this goes to the foundation level. Okay, and it will require more concrete cover, so let's take this to 250mm. Okay, and the depth of our beam, which is the height of the beam, let's take this to 1000mm, so which is 1 meter. Okay, so we can use this proposed first floor beam locations to also guide us on our foundation beam locations. Okay, so of course we will have the first beam running at the perimeter from this section up to this section here. So let's close this and let's see what we're able to model so far. So if we come to the 3D, as you can see, this is the beam that we've been able to model. Okay, this is the foundation beam we've been able to model. So I'll come back to the plan view. I'll select this, then I'll take the properties as well, and I can draw this perimeter beam from here to here, and I'll extend this from this point to this point, and I'll drag this up from this point up to this point. Okay, then this is okay, and I can start with my internal beams. All right, so for the internal beams, I will start this on the demarcation between these two sections. So I'll draw this beam here, and at this demarcation I will also draw this beam to, let me draw to this point. Okay, then I can run this beam from here to here on this column as well. I'll drop this here, and I'll make this rest on this beam. Okay, so I can further divide this beam from this column point to this column point, and also from this column point to this column point. Okay, so I can also divide this from here to, and divide this section from here to this point. Okay, and divide this from here to this point. All right, so the next is I will draw this from here to this point, draw from here to here, extend this beam across the location up until it rests on the beam. Okay, so let's turn off this, let's turn this off, and this are what we've been able to do so far. So I should need another beam from here to this point. Okay, which goes up the way down to here, and also from here to this point, which also rests on this beam over here. Okay, so with this I should be satisfied with my beam panels. So let's come to 3D to see what we've been able to do so far, and this is what we have on the foundation level. Okay, so this is how you can model your foundation beams. So I'll come back to the plan view on my story 1, and the next step will be inserting our slabs on this very model. Okay, our foundation slabs on this very model. So I will come back to modeling, and I will click on slab. Okay, then for our foundation slab, we'll be taking the thickness of our foundation slab as 250 millimeter assumed, and we'll edit this to 250 millimeter. Okay, then we'll come to the loading as well. The self weight has been automatically calculated. Our dead load for here, we'll also leave this as room. Our imposed load, this is still for a domestic use, so we'll leave this as it is. Then our concrete cover, and for our concrete cover, due to the fact that this is going to the foundation level, we'll increase this from 25 millimeter, and we can adopt 30 millimeter for our slab. Okay, so we can drop this, and if we close this and take a 3D look at what we've done, you will see that this slab we just positioned is actually was on the ground. Okay, but it needs to come up and flush with the level of this beam. All right, so we'll click on this, we'll right click, we'll come to the properties. Okay, And to bring this to the level of this beam, what you need to do is subtract the thickness of this slab from the thickness of the beam. So in that case, we should be having 1000 millimeter, and we subtract 250 millimeter, which is our thickness, and this should give us 750 millimeter. Okay, so I will come here to the relative level and I will change this to 750. Okay, and I will update this. So as you can see, this automatically flushes with this very beam sections. So we'll come back to the plan view, we'll select this, we'll right click, take the properties coupled with the relative level, and we can place it on all of this beam section. Okay, so at this point we'll be able to complete our slab modeling, and let's come to 3D. So as you can see, we have this completely modeled at the foundation level. Okay, so the next phase will be what, heading on to our analysis and our design phase of the raft foundation. To design our raft foundation, we will start with the slabs and we'll transfer this load from the slab and we'll design what, our beams. Okay, so to design our slab, I will come here to modeling as well, and I will click on slab strip. So during the analysis and design of our floor slab, we use the analytical model, but if you are designing for a foundation slab, you have to use what is known as the finite element strip. Okay, and if you also observe our boundary condition here, we have what, beams surrounding all these sections. So we'll start from the X direction, so we'll click here, slab all over here are from beam to beam. Okay, so we'll start with the X direction and we can draw this from this point. Hold your control, we'll draw this to here, we'll click here and we'll draw this to this as well. Then we'll click this point and we'll draw to this point. Then the next will be the Y direction, and we'll select from here up to this point. Okay, we'll also draw from here to this point, we'll draw from here to this point as well, from here to this point. Okay, this to, okay, we'll draw from this point to this point. And for this last one over here, we'll start from beam and this ends on a slab section. So we'll start from beam and ends on a slab. So from here, this ends on what, a slab. Okay, so we can close this and we'll come to the analysis of this slab. So to analyze this slab, come to the analysis tab and you click on FE Raft Foundation Analysis. Okay, so we'll click on FE Raft Foundation Analysis and you click this part here, which is Raft Foundation Mesh and Analysis. Okay, so you click this part. So you give a few seconds to load and it will lead us to where we will generate our model. So this has been loaded successfully, and you click on this point to generate the model. Okay, so you can increase this plate number size, you can increase it to about 100, 120. It all depends on your preferred choice, but a higher plate number choice leads to smaller mesh. Okay, and this leads to a more detailed design. This means it leads to a more detailed analysis. The only difference is it will take a lot of time to load. Okay, that's just the difference, but this default section is actually okay. So I can close this and give it a few seconds. So if you come back to this other tab, you can see this has been ticked green because we've successfully completed the analysis. So let's go to the post analysis tab, and this is where we can set our bearing capacity. Okay, So the soil bearing capacity of this soil, this is this is 110. Let's say this is 110 kilonewton per meter square. Okay, and we'll come to analysis post processing. So you can edit the positive and negative moment factor in case you want to reduce the moment, or you want to increase the moments that will be used in the analysis and design of your slab. So this is our generated model, and we can see the so this is open up, and we can see the deflection of this slab. Okay, you can see the displacement of this slab in animation. So let's stop this, and we'll turn on our standard contours. Okay, so this is the value of the maximum displacement, and this value, right, this place that you can see the maximum displacement here, you can see it is around this part where we have what blue. So this is how you can read this value. Any value you see over here is around this point. Okay, while the values in blue, just look for the specific areas where we have the blue colors. So these are the values that are acting, or these are the displacement values that are acting around this point. Okay, so you can multiply this by 1000 to get the specific displacement of this raft foundation. So the next thing, we'll be investigating our moments that are acting on this raft. So we'll click here for the moment on the x direction. This is the moment on the y direction. These are the different points where they are acting. So this on the y direction is acting at this point where we have red. If you take your mouse here, you will get a value closer to this. Okay, while if you take your mouse to this point and you observe this point as well, you will get a value that is closer to these other values. Okay, so this is our torsional moment on the x and y axis. This is the bending moment acting on the x axis. You can relate these values to this. The bending moment acting on direction 2, and the torsional moment. Okay, then the moment that we use in our design, this is the design moment acting on the direction 1 at the bottom zone, acting on direction 2 at the bottom zone. This is the design moment that was used for the direction 2 at the top, direction 1 at the top zone, and also direction 2 at the top zone. Okay, so when designing your raft foundation, there are two take homes you need to get from this point. Okay, the first is your area of steel, and the second is your soil pressure. All right, so your area of steel will give you an idea of the area of reinforcement, that, or the reinforcement coupled with the spacing that will be used in the construction of this raft slab. Okay, while your soil pressure, we compare the soil pressure experienced from this slab to the allowable. So to get a better understanding of these factors, you need to understand the concept of raft foundation design, and I will advise you go through our specific video on raft foundation analysis and design. We have a specific video on that very course, which is about an hour, and due to time we cannot combine that 1 hour tutorial to this very case, and that is why we made those specific tutorials. But we are just going to run through the basic principles for better understanding. Okay, so when designing your raft foundation, you should understand that the main elements are responsible for catering for the load that comes from the superstructure, and also responsible for the soil pressure, okay, acting from the ground, is your raft slab. And by the reason of our style of modeling, we have this slab resting on our beams. Okay, so the raft slab receiving the load from the superstructure, and also receiving extra stress from also receiving extra stress, which is the soil pressure, should be able to transmit this load successfully to the surrounding soil. Okay, so if this is not able to transfer this load surrounding to the surrounding soil, since this is resting on the beam, we can help this slab by creating a larger area of slab around the beam. Okay, so it can help us transfer that load to a larger area. So like I said earlier, to grasp this full knowledge, just go through our raft analysis and design course, and you'll be able to get it in full details. Okay, so we'll come down here, and the first take home will be the area of steel. So if we click on this, and this is the area of steel required to construct this slab at the bottom on direction 1, the direction 2 as well. Okay, that's for the bottom zone, the top direction 1, and the top direction 2. So these values are or this stress are, these values will be used most especially for this point, but you can use it conventionally for the top reinforcement. Or to understand this better, let's bring out our cross-sectional area table. Okay, so let's bring this out to relate with these values. So if we drag this, let's increase this. So we have what the area of steel required at this place as 518. This should be 518. So if we come to the steel table and we look for, let's say we are using Y12 to construct this slab, let's look for 518. So we can see we can use, it means we cannot use Y12 at 250 spacing, because this will give us 452. So you should know our area of steel provided should be higher than our area of steel required. So it means we have to use what Y12 at 5, we have to use what Y12 at 200 millimeter spacing in order to construct the top of this slab. Okay, so if we come back to, let's come to the bottom, and we should be having this almost the same value. If we bring out the steel table, so we can still use Y12 running at 200 millimeter center to center spacing. But if you're designing for a raft foundation, I will advise you use the second area of steel required, which has your wood armor effect, because this wood armor effect takes note of your torsional effect. Okay, so I will click on this to get my reinforcement that will be used for this part, which is 522, and the reinforcement for the direction 2, so this is 571. Okay, so you can relate that to your steel table as well. The top reinforcement, this is 421, so it means we can use Y12 at 250 millimeter spacing for the top reinforcement on the direction 1. And let's also check on the direction 2. Okay, so we can use 559, and on direction 2 we have what 559. So it means in this case we should be going for Y12 at 200 millimeter center to center spacing. All right, so this is the first take home from this very place, and the next will be checking our soil pressure against the allowable. So if we click here, okay, if we click this soil pressure, as you can see over here, the maximum soil pressure here is 261. Okay, so if you take our mass to this point where we can relate with this value, if we take this to this point, you can see what we have here. We have 222.797 is greater than 154, and is giving us a warning. Okay, so it means this raft slab cannot transfer this load successfully to the surrounding soil. Okay, so we have to create a larger area to this slab, and due to the fact that we cannot create this at the top of our slab, we have to create it at the bottom, and at the bottom is where we have our beam. So we'll attach this extra area of slab that will help us to transmit this load to the footing of our beams, and this is what is known as the apron, or this is what is known as the cantilevered footing. Okay, so this value that we have here as 154 is gotten by multiplying our soil bearing capacity by our factor of safety. So the factor of safety defined for this very project is 1.4, and like I said earlier, to better understand this raft foundation, I will advise you go to our detailed video on raft analysis and design. Okay, so like I said, if we come to our calculator, right, we use a soil bearing capacity of 110, and if we multiply this 110 by 1.4, okay, we should be having what, this 154. All right, so the soil pressure at these edges should be lesser than this allowable. Okay, should be lesser than this allowable soil stress. So we'll come here, and this, as you can observe, these are the points where we are having these values. If we take our mouse to this blue zone, you can see the allowable soil stress we have 20 is within the range of 23. So it's within the range of these other values that we have over here. Okay, so where we are having issues is mostly around the edges, because this slab cannot transfer this load successfully to the surrounding soil. So to cater for this issue, what we need to do is create our cantilever footing or our apron. Okay, so if we close this, and we'll not transfer the foundation results, we'll close this, and let's come to the 3D. Okay, so it means we need to provide a larger area of this slab, but we cannot do this at the top. We have to do it at the bottom. Okay, we have to attach this to the beam, so the load can come from the slab, go to the beam, and transfer successfully to the surrounding soil through this cantilevered footing. So we'll come back to the plan view. Okay, and we'll click on this slab, we'll right click, we'll come to properties, and we'll change this from this section to a cantilever section. The thickness of our slab, we can reduce this to 200 millimeter of our cantilever slab. Okay, and the relative level, let's take this to 0. All right, so we leave the loading as it is, and the length of our cantilever footing, let's take this as 600 millimeter. Okay, so we'll come here, we'll draw this from this point, and we'll take it to this direction. Okay, this is giving us a warning that this will alter the previous analysis that has been done. We are okay with that, we already know that, so we'll click yes. Okay, then we can close this, and let's take a look at what we've done. So this is the cantilevered footing attached to the base of this foundation. Okay, we'll click this, then now we can now take the properties of this, come to properties, we'll come here, we'll draw to point. So we'll just follow this procedure and draw all around this foundation beams. Okay, so far we've been able to complete our cantilevered footing, and if we come to the 3D, so we have this cantilevered footing at the base of our beams. Okay, so let's come back to this point, and let's head on back to our Raft foundation analysis. So we'll click here and we'll replace. So click here, the Raft foundation mesh analysis, and we'll replace the previous results. Okay, so we give it a few seconds to load, and we can generate our model. So we'll close this, and we'll come back here to edit this to 110. Okay, and we'll go to analysis post processing. And on the analysis post processing, we'll turn on our contours as well. We already understand what this is all about. So our main area of concern at this point is the soil pressure. Okay, so let's come down to this part. Okay, and let's look for our soil pressure. So as you can see over here, the value we have is 111. Okay, and this is lesser than 154. So this is to tell you that the additional 600 millimeter cantilevered footing of 200 thickness is sufficient, and has helped us to transfer this load to a larger area. Okay, so since this is 111 and this is 154, all right, you can as well start yours with possibly a 500 millimeter cantilevered footing or a 200 millimeter cantilevered footing. or possibly you can start it with a 500 millimeter cantilever footing but having a thickness of 150 millimeter. So this is just the processes of your design, just so you can arrive as a very cost effective design. But at the end of the day, you should never joke with your allowable stress. Okay, this must be greater than what this. Okay, so at this point in time, we've been able to complete our raft foundation slab analysis, and we'll move on to designing for the beams. So let's go ahead to close this up, and in this case we can now transfer our finite elements raft foundation analysis. So our analysis has been completed, and we can now transfer the foundation beam result. Let's transfer the results to our foundation beams. Okay, so we'll close this, and we've completed what our raft design. So the next phase will be designing the foundation beams, and to do that, let's go to design. If you found this video helpful at any point, do not forget to like, share to your friends. If you have questions, if you have concerns, always leave them at the comment section, and we'll do our possible best to always attend to them. Okay, so in this case, we are no longer designing our story beams, but we are concerned with the foundation beams. Okay, so to design our foundation beams, there are a few settings we need to make, and we'll come here to settings and parameters. Then we'll come to beam. Okay, let's click on parameters. So under the parameters, we'll leave this floor beams, and we'll come to foundation beams. Okay, so the minimum steel bar diameter we should be using is y16. The maximum should be y25. The minimum hanger bars is y16. Our link diameter should be, let's use y10 for the link diameter. Okay, then our concrete covers from the beam top to the edge will adopt 30 millimeter. Then the beam bottom, okay, since this part is having direct contact with the soil, I'll prefer we go with a higher concrete cover. So let's go with a concrete cover of 50 millimeter. And for the side of our beams, okay, this is from the top where it's connected to the slab. This is from the bottom where it's connected to the soil, and this is from the side, okay, both to the left and the right. So we can adopt a thickness of 30 millimeter for our beams. Okay, so we will leave these other settings as default, and one thing I would like to change here is our maximum link spacing. Okay, since we are designing a deep beam, there will be higher shear stress. Okay, there will be possibility of higher shear failure. So I prefer we change the maximum spacings between our shear links, or our shear reinforcement, or our stirrups as we may call it. I prefer to change this to 250 millimeter. And like I always say, if you need to get a detailed analysis and understanding of this raft foundation design, just go to our video on raft analysis and design. You'll be able to get a detailed approach of each of these values. Okay, so the maximum support, the maximum span is we'll also change this to 250 millimeter spacing. Then we can click OK, and we can perform our beam design batch mode. Then we can reselect all bars and calculate this. So if we close this, you can see all our foundation beams has been designed, and what we just need to do is check the reinforcement that is required to design this foundation beam. So if we click on this, so as you can see, the top reinforcement here we have what 2 y20, but we can modify this to 3 numbers of y16. Okay, we can also modify this to 3 numbers of y16. We can also modify this to 3 number of y16. This is for the top reinforcement. So we'll change this from 2y20 to 3y16. Okay, so this is how you can edit your reinforcements. Just go through our raft foundation analysis and design course. You'll be able to get better understanding. So for our bottom reinforcement, okay, we'll change this to 3y16 as well. We'll change this to 3y16. Okay, and due to the time we've already spent on this video, you can do this on your own. You can get the CAD file, go through all these processes, and you can edit this to suit your own preferred method. So as you can see here, this is the bottom, this is the web reinforcement. So if we come to detail this drawing, let's detail this very beam. So this is the beam in question. Okay, so our A here represents our bottom reinforcement, which we've modified to y16. So we have 1 2 3, which is AAA, and AAA here means A is y16. So we have three numbers of y16 at the bottom, and over here we also have what CCC, which is our C is also y16. So we have what three numbers of y16 at the top. Then at this point as well, we have what our B, which is our web reinforcement. So we have three numbers of web reinforcement to the left and to the right. So this shear reinforcement is helping you to maximize the capacity of your beams against the shear failure, okay, because the load is coming here, and if you don't have enough spacing between these links, these are your links here, then this can fail in shear. So this is your web reinforcement. So we'll close this, and the web reinforcement, like I said, we have what 3y16, and this will go both to the left and go to the right. Okay, so this is how you can perform the design on your foundation beams. So far so good. We've been able to complete the design of the superstructure, and we're able to complete the design of the substructure. All right, so what we just need to do is let's right click, and we can update the steel bars that will be used in the construction of this slab. Okay, so what I would advise is you redraw this slab strip from a cantilevered edge to a cantilevered edge, okay, before you rerun your analysis, so it can provide the reinforcement required. So here we have what y12 at, we have y13 at 250 millimeter, and you can also use your steel table to detail this manually, okay, just from the understanding that we got from the post analysis and design phase. So with this, we've been able to complete this full design course. And if at any point in time you found this video helpful, please do not forget to like it, do not forget to share, do not forget to comment where you have concerns so we can help to clarify that. And do ensure you support us by getting the CAD file from our online store, and you practice with us. And if you have any concerns, you can always relate with the team. So thank you, and see you in the next design course. Okay.